Supermicro. It's great to be underway.
You're muted.
And it starts even better if I'm not muted when we begin. It is, of course, the vBrownBag way to mute the presenter. Welcome to the Build Day live event here at Supermicro. It's great to actually be underway. We've been here for a few days building out the environment and just generally getting to know Supermicro. There's quite a lot that I'd assumed about Supermicro that turns out to be wrong. So it's great to learn some more. Now, joining me is Sim, and I'm not going to mangle your last name on camera.
Sim Upadhyayula.
Thanks, Sim. Sim is, well, we decided your role is not what your title is, and your title is not what your role is. So,
exactly. So I am a Senior Director at Supermicro Solutions Enablement. My role here has me talking to the end users more. It's more like customer facing, understanding the needs of the enterprise, understanding the needs of the service provider customers, and matching up their requirements to our product portfolio. So what is happening today is that many of our customers are too busy focusing on their business outcomes. They don't have time, nor the energy or the resources to focus really on what is the right infrastructure for them. So in that sense, they kind of lean on us as a trusted advisor, or like a thought leader kind of a thing, to let them know what are the different things available, how they can kind of maximize their investment in infrastructure so that they can deliver much predictable business outcome to their customers.
And that sort of consultative thing is something that I was not aware that Supermicro did, probably because down in New Zealand we don't have particularly large customers, and you probably don't have badge staff in New Zealand, although there are Supermicro badge staff all over the world to do these engagements. Now, in addition to Sim, of course, we, as always, have Jeffrey manning the cameras and making sure we all look good. Jeffrey, you've also done some research around Supermicro and some of the history, and just wanted to give us a little profile of what Supermicro is and does.
Yeah, absolutely. You have to forgive me because I'm running a couple different things here. So, Supermicro been around since 1993 when it was founded by the CEO and President Charles Liang, the senior Vice President of Operations now Sarah Liu, and Wally Liao. Did I pronounce all those names right? They have been a growing company, 850 employees in 2008, and now currently at about 2,700 employees. The BigTwin that we're talking about was launched in around the 2011 mark as the 2U Twin, and in 2014, the Center of Tokyo Institute of Technology's Tsusanbe KFC supercomputer from Supermicro was ranked the first on the Green 500 list. Excuse me. Supermicro Green Computing Park in San Jose, which is where we are right now. It used to be the San Jose Mercury News headquarters up until about 2011, and then of course Supermicro took it over to, and there's several buildings on this campus. 2015, that's the X10 Twin Pro rebranded to BigTwin, which is what we're going to be talking about today. And then one more interesting note, Supermicro is big on planting trees. They've planted several redwoods and bamboo. In fact, if you go right outside this door, you'll see a whole bunch of bamboo stalks getting started in their journeys into keeping this environment even greener as possible.
Well, thanks, Jeffrey. And so 25 years.
25 years, very exciting. Still the same startup culture, still the same passion from the day one, what Charles set out to do, right? He's the man who leads our company. He is as passionate as he was on the day one. Even to this day, he comes in at 8 a.m. in the morning, and he's the last one to leave. He's the one who turns the lights off. And when he leaves, before he turns off the lights, he looks up at the building, what he built, and says, I can do better. So that is a passion. That's a passion that he brings to the table. Yeah. And that is what each and every employee of Supermicro is kind of dedicated equally to that cause.
And I do feel, having spent a few days here, and this room that we're in is immediately off the staff cafeteria. And it does feel very much like there's a strong, solid culture in here. There is a sort of cohesive feel to the place, and it's fostered to build that. The whole organization seems to be built around having that.
They still have...
I should say you're spot on your observation. Because when you look at it, it's more like a family. And when Charles is very clear, when we kind of bring some member into our team, he tells us one single thing: you're bringing a family member, make sure we have the resources to make that person successful.
That's an
And there were
awesome
instances when we thought, you know what, this candidate is really good, but let's hold off until we make the infrastructure, we can provide the good support structure around for that customer.
so that the growing pains as you've gone from that 800 staff to close to 3,000 staff are minimized.
And first of all, I have to apologize to the audience because my volume wasn't up. So hopefully you heard everything that I said there. So, but they also, what I understand is every Saturday they have a lunch that they can go to.
Yes, every Saturday they have a lunch. All the employees have a lunch, and that is where our CEO Charles also joins in. All right, and that's when we have an opportunity to sit down and talk. And it's one of the companies. I have worked in several different companies in the Valley, but this is one company, despite its size, he still knows almost all the employees by the name, all right? And it's an open door policy. Whenever there is something wrong, you can kind of approach him. So that culture, that family thing is what kind of makes us different and unique in this particular Silicon Valley and in the industry itself.
So yeah, very cool. And I guess we should talk about what we're going to do today in the live stream, what we're going to build, because of course that's the whole point of the build day, is to build something. And the headline product for this is the BigTwin. So we're going to take the 4 nodes and 2U that we've seen from lots of other vendors. So this form factor I first saw as the Nutanix products, and to this day the Nutanix products are primarily built on the Supermicro platforms. And that's a really cool thing that we're going to build out VSAN on top of that BigTwin, because you don't have to buy it as an appliance from a software and hardware vendor, although lots of people do, because the other things I was thinking through, the people that I interact with, so Cohesity, Rubrik, and the NetApp SolidFire HCI, these are all based on the BigTwin, aren't they?
You said that. I didn't say it. The reason why is because just like Jeffrey was introducing Supermicro, we are many things to many different customers. Some of us look as an OEM. Some say that we are an ODM. Some say that we are a chassis provider. Some say that we are a system provider. And to be honest with you, we are very close to our customers. We enabled so many different customers in this valley, like right? But we never kind of mentioned them by name, because we wanted to kind of ensure that privacy to them. So like you can say that we are the guys who are behind the curtains and make it happen all. And case in point, your point was spot on, right? Twin architecture.
Yeah.
We are in currently 5th generation of BigTwin. That is the BigTwin that you saw we're kind of alluding to. And the twin architecture was the first, we were the first ones to get along with Intel on the twin solutions. And at that time, when all this hyperconvergence movement was starting, it was very, very important that you have a form factor which is more condensed and at the same time can kind of encompass everything and provide the picture of everything in a box. For that you needed 4 nodes. And the form factor, obviously, the smaller the footprint, the better it is. So 2U is what was required.
But
and nobody
still with
had
that
one.
Small form factor, we still wanted full power machines, because there were, at the time there were small form factor, but they were absolutely wimpy processors.
So some would say it's an engineering challenge, but that at the heart we are an engineering company. Today, when many people do not know about Supermicro, it is not because of our lack of innovation or lack of engineering. We bring the best products to the market. Everybody knows that. But we focus more on engineering and less on marketing. So probably that is another reason that awareness is something which we are trying to kind of change now slowly, right? Yeah, when it comes to engineering, we are the best company bar none. And we are the ones who kind of always are willing to take risks and to change the status quo. For example, the Twin Pro Square that you had, the 2U4 node that Jeffrey was talking, that is what the hyperconvergence movement started on. We didn't rest on our laurels, right? The BigTwin is now the next generation of it. We still have the Twin Pro Square, by the way. We haven't, it still is very much a platform that is still customers use it, right? But with the BigTwin is, the challenge was like you mentioned, once you kind of put a form factor, you're boxed into that form factor. So you're stuck with the 2U in order to get the compactness, the conciseness. But then again, in order to pack more stuff in it, how much can you pack in a 2U? That was what many people were looking at Supermicro and said, this guys are done, they can't do any better, this is the end of it. But time and again, year after year, we were able to surprise them. It's just like one of those car ads. Just when you think 8 people popped out of that small car, that's about it, out come 2 more. So that's how we did it, right? And to be honest with you, if you look at it, we stuck to the same 2U form factor, 2U 4 nodes. Today it's a BigTwin, which has the highest wattage CPUs it can run.
Because I was watching, there's a slideshow that runs in reception here, and it was a 205 watt
205 watts. And that's another thing that I think we are different from many of the competitors out there, because we control everything. We are most vertically integrated. We design our own motherboards. We design our own layout of the motherboard. And that's how we started our journey in 1993. He was a man like Charles Liang. That was the time when mainframes were kind of popular, but then when people were looking at it and moving to more like a rack systems kind of a thing, right, as x86 based equipment. And he said, servers are getting popular, but they are like energy hogs. They're big, bulky. I can do something better than that. And that was the genesis of Supermicro. The motto is still the same. We can do better, right? So that's how we started. So today when you're coming back to the BigTwin, you mentioned how can you do it? If you look at Pro Square, right, the 2U4 node that started the hyperconvergence and all those things, good things, the form factor is the same, but when you look at it, the node has a little bit wider because to make sure that we accomplish that higher wattage of the CPUs and also do the NVMe and all the drive density kind of a thing. So what we did was we kind of redesigned our power supplies. So if you take out the power supply from a Twin Pro Square and a BigTwin, this is a skinnier version of it. But don't go by the size and the far shape because it's much more power efficient.
Because it goes to a 2600 watt. And we've got a video on that where we do the hardware tour. So we will have that hardware tour video for the BigTwin. And Jerry Chen talked about how reducing the width of the power supply by 30 millimeters meant that there was enough space to put more DIMM slots on the motherboards. So we'll play that video in a little while. So the other things that we're going to show in the live stream today and demonstrate is some of the leadership around putting GPUs into servers. And although what we're going to show is a single GPU in a server because it's a 1U server, you've got some good products that are higher density in GPUs as well. So we'll show a VMware View hardware accelerated 3D graphics.
Absolutely.
But we've also got a video to show of more of the portfolio for all of the GPU accelerated, and there's some really interesting products in there. While we're thinking about the content, there is also for the first time going to be an ebook and even a print book that accompanies this build day. So our friends at Actual Tech Media are doing a guide Build Day Live edition for the Supermicro Build Day Live. The ebook should be available by VMware. We're hoping that the printing gods will favor us and that there'll actually be paper copies available from Supermicro at VMworld US as well.
Get excited, yes.
Yeah, that should be a really good book because, of course, the Gorilla Guides are always a good hands-on reference to the materials. So what else? We're going to show build out of the BigTwin with VSAN. We're going to show deploying or running a hardware accelerated 3D graphics in VDI. So I guess the first thing to do is to look at what we started with, what the customer environment was beforehand, because of course, as always, we don't let you build the environment you dream of having. We bring our own potentially broken environment with us, just like a real customer. So it's the usual Build Day Live mobile lab. Funnily enough, it's all Supermicro hardware, and it was even before we had any relationship with Supermicro. We have a 3 in a 4U travel case, and they're the little tiny, 2 of them are the SYS 208D, the little Xeon D machines that will take 128 gigs of RAM and a M.2 NVMe drive and a SATA drive as well. So those are the two in the workload cluster. And then I've got now a 308D, and that's the slightly larger enclosure with only a 4-core CPU, but it lets me put more expansion in there. It's got a whole heap of networking in there. So that's my management cluster, is that one host. It's currently built as a VSAN environment, and it's built using AutoLab, my vSphere nested lab that builds itself. I really do need to do the blog post about how to use AutoLab to deploy physical servers, because that's what we're doing here. So I'm not going to be using ISOs to install ESXi on the BigTwin. I'm going to use the AutoLab PXE boot. And that's, in fact, even how I built my, my existing cluster that's in that box. So I guess we should dig straight into it.
Absolutely.
The one thing that we have pre-configured is that we've set static IP addresses on all of the ILO cards in the 4 nodes. So it's 4 independent nodes, 4 independent ILOs, and so 4 different IP addresses. They come from the factory configured for DHCP, but I've just set static IP addresses because that's the kind of person I am. I like static on there. And the first one is sitting at 168.199.213. And we just log in with the standard. Capitalization is fun in remote on here. I'm typing something wrong. So this is the newer firmware on the IPMI. I'm choosing to do this manually, but I understand there's Redfish integration on the IPMI, or at least on the management controllers.
There is a couple of different ways you can do. The Redfish API is there, and then there is a vCenter plugin also to make some of these things simpler. And this is where I think as a company, we are more willing to listen to the customer feedback, because that's what made us successful, right? And many of our customers were saying, you know what, it's a great product hardware wise, but software is a little bit, management tools are a little bit, leaves a little bit more to be desired. So that's what in the last few years, if you look at it, we made huge improvements. Everything is now Redfish API. All our products support the Redfish API. That way, if your customers want to kind of, use scripting, right, they can always do that. Then we have the CLI also, and then we have the GUI also. That way, there are multiple different ways to kind of, depending upon your choice.
But it's one of the themes that's come through is that it's a choice for the customer.
Exactly.
That you're not retiring an old way of working, because if you've got a customer that has 800, 8,000 of your servers, you don't want to force them into using a mechanism that's unfamiliar to them.
Absolutely.
You give them the opportunity to continue to use. But for the customer that wants the latest, you probably have a product that supports the latest standards or pre-standard.
Yeah. So like you rightly said, right, there are some enterprise customers who wrote their scripts and they want the CLI to be a certain format. We respect that, we never change that, right? And then there are new age customers who want to kind of do differently, and we kind of provide a path for them too.
All right, normal boot up of a server, of course, it takes a little while to get started. And initialize all of the parts. And in addition to the standard menu-based PXE boot, I have, just to make things easy for myself in here, I've set up a PXE boot environment where, come on, hopefully that PXE is going to kick. Come on, tell me you're booting from PXE. I've set up my PXE environment so that each of the physical servers, when they do PXE boot, they automatically install the correct configuration of ESXi. That one has missed my PXE. I was probably looking away at a moment when it prompted for PXE, so I'm just going to repower cycle it, and hopefully I'll pay a bit more attention this time. When we do hit the PXE boot, it's going to take a custom config just for this ESXi server and do the full build, so we don't need to watch through that process. But one of the things I was trying to see in this is whether the value proposition around hyperconverged is partly around really easy deployment.
Make it simple.
And so if you buy a hyperconverged product from a hyperconverged vendor, you get that baked in. But we often compare it with how hard it was to build things 5 years ago when hyperconverged was brand new. And that's not a valid comparison, because you're comparing to what's it like to build now. So I wanted to see what the experience was that would be, if I was an enterprise customer who was deploying maybe 5 or 10 of these BigTwins, what automation would I have in to make the job of deployment easier? So I have deployment automation. It's just simple Pixie, and it's configured to do the full build. And then later on, we'll use some PowerShell scripts, and people who have watched the build day live before will be familiar with my PowerShell scripts to do the builds. They, again, come out of AutoLab and make configuration easy, and the sorts of things that customers would do for real with these products if they were deploying them.
Yeah, you're absolutely right.
Now we're doing Pixie.
Like you, many of our customers, when we sit down with our customers, they say, you know what, make it simple enough. Let me focus on my business.
Yes.
Make it simple. And if you look typically at the different stages of a data center, life of equipment in a data center, right? Number one is sizing. What kind of equipment do I need? How big it is? Is it really easy for me to scale in the future? How granular can I scale? That's an important thing. And the other thing is obviously configuration. I don't want to, like you said, 5 years ago, if you were to do something like that, you would sit down and make sure that different components really are certified, whether it will work together and all those things. That itself probably would have taken a couple of weeks.
Yes, and then you find a few months later that one of the components is no longer certified.
Yeah, so that's the thing. And the third thing is ordering, right? How can I order? Do I have to do it as a one SKU, or is it much more complicated? And the fourth thing usually is deployment. That is when pedal meets the metal. You want everything to be done in a smooth manner so that you can really take it to production rather than sitting on the sidelines for weeks together trying to figure out getting all the things together, right?
Getting the time to value from
time to value is very important to our customers today, right? They don't, because that's the age we live in, the digital age. Everything changes so fast, and the requirements are also really they change on the dime. It's like up and down, right? And the last thing more important is the maintenance and manageability. How easy it is for me, and if something goes wrong, what do I do? So all these 5 different steps, we made it very simple. So if you look at it, simplicity plastered all around it.
Yeah. Well, I think I have 3 more to build, and that automation, although it's automated, it takes some time. So I think, Jeffrey, if we can switch out to the hardware tour of the BigTwin that we did with Jerry to look at the actual insides of these machines and see some of the cool features.
Which one?
The hardware tour of the BigTwin, please. And just to see that conversation we had about the engineering of the platform and all right.
So that's one other thing, right, where we were talking even when Jeffrey also introduced. It is often Supermicro is misunderstood. The reason being we do a lot of different things for different customers. So today, if you were to kind of define Supermicro, I would say it's an end-to-end solutions provider. That way, whatever your needs are, from the day one, from the sizing to final deployment and the management, that is something which we do. So it's like more like a one-stop shop. So that's something which needs to be told, communicated.
All right. Well, I think we're ready with the video now.
Yep.
Would you like to bring that in, Jeffrey? Welcome back to the Build Day Live with Supermicro. We're going to take a look at the actual hardware of the BigTwin that we've been building today. And joining me to go over that is Bill Chen. Welcome, Bill. And can you tell us a little bit about what you do at Supermicro?
I'm the senior product director in the server department, and BigTwin and the Twin family is my major product here.
And it's one of the biggest selling products for,
That's right.
for the company.
BigTwin is our major product in the Skylake platform.
Great. And this is the what was, when I first saw it, revolutionary 4 servers in 2U form factor. Run us through a little bit how it's different from a rack mount server and how it's different from a blade enclosure.
Okay, I think we can talk about the Twin family. Back in about year 2007, we designed the first 1U 2-node system we call Twin family. We start from that, and then we got very good feedback from customer side, and then we start to design the 2U 4-node system. so we call Twin Pro. And we also have very good result on the Twin Pro. And after that, once go to the Skylake platform, we found there's some bottleneck there, because in this form factor, we have a limitation on memory design, memory population, right? So at that time, we try to see how can we put in 24 DIMM in this form factor. So that's the reason we come out with a BigTwin solution. And the major key factor is that we have the special power supply design we call power stick. And this power stick design can let us to have more space on the motherboard. So you can see the so skinny, this is only 38 millimeter width, compared to a regular power supply is only half of this width. So that's the reason we can have more space on the motherboard to support a 24 DIMM memory.
So that's extra width to have the extra banks of DIMMs either side of the CPU
right.
sockets, because you're very constrained about how you can lay things out when you've got a very long, thin platform in here.
Yeah, that's why compared to the other solution, that this one can support more feature. That we call it no compromise any feature compared to the rack mount server. So in the rack mount server, normally you can see that you can put a 2 DIMM CPU, 24 DIMM memory, a lot of expansion slot, and it's I/O. So in this 2U4 node system, not compromise any feature compared to a 1U rack mount server.
Yeah, you get the same functionality in each node as a 1U rack mount server.
That's right.
But you get 4 of them in 2U. And you get simpler cabling to a certain extent because you're only running 2 power supplies.
Yeah, so we run 2 power supply, and that's the key, right? This power supply, we support up to 2200 watt, and also we have a 2600 watt version for customers if they want to have a higher bin of CPU, or you want to fully populate memory. Right. We also have a 2600 watt power supply, so share with the four computing node, so that you can have a more power saving, have a better power efficiency. Right? So and also this is 1+1 redundant power supply. So even one power supply is fail, the 4 nodes still continue
still at
running.
Full power.
Correct.
That's great, and yeah, fits very nicely with a dual PDU rack deployment. Can we take a look at that node that we've got eased out? Sure. Because of course, 4 nodes. Well, there's 4 of these servers, so that's the equivalent of a 1U rack mount server in there, and
we use a 0.5U space.
Right. So half width, 1U height, and so standard 1U type heat sinks in there. Although I imagine there's a fair amount of engineering of your own done to it, because there's actually a pipe through the middle of this one that is clear, so that some cold air hits the heatsink for the rear CPU. So there's some really interesting engineering going on in there. Yeah.
So here you can see that we have the a pipe to direct the hot or cold air to the back end side. So normally the 2 CPU front and back, you have about 10 degree
differential.
Yeah. And so that's why we have this design to balance that, right? So that's good for cooling. And then we have a 24 DIMM. You can see that all 24 DIMM can be populated.
Yeah, and in the lab we don't need that much memory, and it costs a lot of money to fully populate them. If you're not going to use it, you don't need to.
But for the 24 DIMM design, the one benefit that normally customers they have some configuration say that they need a 512 gigabyte memory. And in that case, you normally will put a 16 DIMM or 32G, right? Yeah. And right now, compare the pricing, 32G and 64 gigabyte memory. 32G still have a sweet spot there, right? Yeah. So we can put in the 8 DIMM per CPU. You still can get a balanced mode of a memory. But if you use a 16 DIMM design of the motherboard, then you need to fully populate the 16 DIMM. That would be unbalanced design, because you have a 6 channel per CPU. In that design, the balance mode is unbalanced. So with this 24 DIMM design, you can have first the better pricing, and also you still get a better performance. More consistent performance with the balanced memory config. Yeah. And then there's some other really cool pieces in here. One of the ones that I hadn't heard before you told me about it, Bill, was this plug-in module here that gives us an option to boot from some pretty cool media without consuming any of the storage in the front of this thing. That's right. So for the storage supporting, right? So we use this we call adapter board to direct the signal from the motherboard to the front side, right? So front side we support each node can support up to 6 devices. You can VMWare VSAN SATA, right? You can count tri-mode. You can based on customer requirement or application, you can select different device.
Yeah.
And other than the storage, 6 device in the front, we have one adapter board here to support to M.2, and this M.2 can be either SATA or NVMe. And normally, the most application using these to load the OS or put a hypervisor in this location, so you don't need to sacrifice any space in the front side.
But I can have enterprise-grade storage for the operating system.
Correct.
And then not compromise on the 6 storage devices for my actual application data in the front.
Yeah, and the good thing that we have a 2 M.2 can be support, and you can build a RAID 1 to mirroring, so that can have better
single media failure doesn't take the system down.
That's right.
Now, we're not using that in this lab for this VSAN build. We're using this other guy. That's the SATA DOM plugged in here. So it's a small SSD on a little card that plugs directly into the SATA port. Personally, I love these for booting ESXi servers because they're way more reliable and better performance than a USB key. But they're not taking up any slots that I could put storage for VMs. I definitely want different separate boot media for my ESXi server from my storage, and the SATA DOMs are really good for that.
Yeah, so yeah, that's the reason we put a SATA DOM and an M.2 option for customer to do to have their own selection.
And that the ability to choose different things and have them work at a really good level is one of the features that we see throughout the Supermicro. And I particularly have seen it this week with the modular. It's not really a LAN on motherboard, but it fulfills the function that other vendors provide by putting a network adapter on the motherboard. You have a modular network adapter that plugs into the motherboard. Can you talk us a little bit about that?
So this device we call Supermicro I/O module, SIOM, right? So you can see that that's kind of like cut off the motherboard portion of the motherboard. So normally you put a network controller down to the motherboard, but however, you know, in this moment, so many different networking solution. You have a 1G, 10G, even 10G you have a base T or 10G SP plus, and 25G, 50G, 100G, and InfiniBand. So many different solutions. So that's why we have this kind of design to let customer to select what kind of networking they are looking for. So they can have a flexible networking, and you don't need to occupy any expansion slot.
It uses the CPU's built-in support for networking, rather than using PCI Express. But of course, you can use PCI Express because we have a couple of slots here, a couple of 16 times slots in the back.
Yeah, so other than the SIM slot, we also have a 2 PCIe by 16 Gen 3 slots. So some not satisfied with only one card with a 4-port only, they need to have a redundancy. So you need to plug in the other networking card. SIM card is from CPU 1, and you can plug in the other card from CPU 2. So we can have a kind of balance networking.
Balance of the PCI buses.
Yeah,
nice. And I could put fiber channel cards or something else in there for whatever my needs were.
So many different solutions.
And presumably I could pass out PCIe to go to a JBOF or some other PCIe fabric as well.
That's right.
Great. Now, the other element that we're showing in this build is using Intel Optane storage. And this is the high bandwidth, low latency, ridiculous transactional performance that you get out of the Intel Optane hardware. This is providing us in the VSAN configuration. A couple of these are providing the cache tier, and we've got some 4 terabyte conventional NAND flash drives for capacity. So these are really cool and provide incredibly low latency and high transaction rates, and of course they're NVMe, so there's lots of queues, and that helps also utilize the low latency of the storage. So I'm quite pleased to have these in. I've not had any experience with Optane before. How does Optane fit in the product set for Supermicro?
So Optane, we start from the beginning. We do the Optane testing for a while already. So it's really the next generation of flash storage is moving towards these really low latency platforms. I mean, they're what's driving NVMe as a technology, is having these low latency, high bandwidth platforms to attach to something. If you attach them to a SATA bus or a SAS bus, that you're just not going to get the benefits of them. So yeah, nice to have these devices in here. And of course, NVMe isn't the only option to have on the front. For those who haven't looked at NVMe, it's PCI Express being sent all the way down to this U.2 device. There are other options for connecting storage to the front of these guys, those 6 storage devices that go to each node.
What are our other options if I'm not going to spend all of the money on the fastest thing you can buy today?
Yeah, so we have a six hot swappable drive in the front side. You can have a NVMe or a SAS or a SATA, or it's kind of tri-mode backplane. You can, based on the model you select, you can have a different storage solution. So normally we have a customer that using Optane, for example, Optane for the caching, and for 2 drive for caching, and the other 4 drive you can put data, because Optane you can use in caching for more lower latency and higher bandwidth.
Yeah, and it also has a much higher write endurance.
That's right.
Than the NAND flash, so it's really good as a cache tier. And then in the lab we're using 4 terabyte SSDs in the other 4 slots, but there are 8 and 16 terabyte options on the market.
So I think to talk about the NVMe, other than the internal storage, we have a 6 NVMe. Like you mentioned about the JBOD, right? Actually, we have the other solution for the JBOD. We can use a BigTwin 4-node connect to the outside. We have a 1U JBOD, can support a 36 NVMe in a 1U platform. So we have 2U BigTwin plus 1U JBOD. Total, we can have a 16 plus the 36. We have a 52 NVMe device in the 4-node system. So other than the internal 6 drive, you can have the other 8 drive.
A lot more attached outside. Yeah,
that's right.
Nice. That would be a ridiculously large amount of storage performance, and I guess to handle that amount of NVMe storage, you're going to need to use something like the Intel scalable CPUs. You're not going to be wanting to use some of the lower core count, because you simply won't get the throughput with a very low core count.
Yeah.
Nice. Well, thank you very much, Bill, for joining us here. And thank you for joining us in the video. And we hope you'll stay tuned for more Build Day Live videos here at Supermicro.
Thank you.
And we're back. The installs are still running. My SXI installs are still progressing. As you'd expect, they take a little while to complete. So while we wait for those to complete, we will hit another of the pre-recorded videos. So we talked about the ultra-dense, full-power blade enclosure with 14 blades with full-on Xeon scalable CPUs. So Jeffrey, I'd like to play that video. That's some really cool hardware that maybe we'll do a build day on another time.
Yep, absolutely.
Welcome back to the Build Day Live here at Supermicro. Joining me for this video is Sing Ging. Sing, thank you for joining us, and what are you bringing us to take a look at today?
Hi, yes, I'm bringing this leading edge. Sorry, I'm bringing this, yeah.
Yeah, we'll start again.
Okay. 3, 2.
Welcome back to the Build Day Live here at Supermicro. Joining me for this video is Sing Ging. Welcome, Sing.
Hi, nice to meet you here.
And what do you do for Supermicro?
Hi, I'm the Blade PM here.
And you've got a pretty cool blade enclosure for us.
Yes, this is the leading edge design 4U Super Blade that equipped with the latest CPU, the scalable family, in this smallest form factor blade enclosure, the 4U available on the market, which nobody has it.
So this is a 4U enclosure with 14 blades in it.
Yes, that's correct.
But it has the highest power Xeon scalable CPU, so it's a dual socket. It's not like it's underpowered because you can't get enough control in here. This is full power CPUs
it's full power
in here.
CPU, yes.
So I can have like 48 cores in each of these.
Yeah, you can populate two CPUs and also full 16 channel memory, and to give you enough memory for in-memory computing.
And is that sort of in-memory SAP HANA type workload the sort of thing you're seeing this deployed for?
Actually, if you want to use for SAP HANA, you want to pick even higher memory capacity blade. We'll have another blade, is AU Super Blade, that can fully populate 48 in one 4-way blade node.
Okay, so this is the big brother that would block both of us out from the camera if we hadn't here. So
yes, that's a big brother.
Right. And so what sort of workloads would be on this one?
So the benefit on this one is it's focused on high condensed infrastructure, so you can put as much CPU in the smallest form factor as possible and still offer you redundant network connectivity from the back as possible.
Because there's two switches in the back of here that I'm not going to turn this thing around because it's a little heavy, but there are two chassis switches in here, and these are options. What are our high bandwidth options in here?
So we have 10G and 40G uplink. Combined, you will have 120G total uplink.
So multiple 40 gig out of each side.
Yes, multiple 40
and
gig.
then 10 gig going down to each of the blades from each switch.
10 gig for the interconnections.
Right. And yeah, 14 servers in 4U, continuing with that high performance. So this is CPU-bound workloads. Do you see much use of this for virtualization?
Virtualization-wise, yes. In a converged infrastructure, once you connect to external iSCSI flash storage, you can use the pure CPU power internally to set up like huge virtualization environment. And if you want to go even higher, I would say memory pool, you will also go use the SuperBlade 8U. Yeah, and the benefit on 4U is because we put everything in cadence, so it help save your utility bill. Once the cool air coming from the front side to the rear, it actually efficiently transfer the heat into the air and then pass out to the hot aisle and suck it out to the data centers. And this is something unique that the SuperBlade can do. The rest cannot.
It's not quite as efficient a design because the thermal design becomes the most important thing when you're getting this sort of density in it.
Yes.
And then this is the sort of thing that you're seeing at large companies in the Fortune 500 scale, putting in rows of racks full of these and getting that thermal, the maximum density for their compute requirements.
Yes, positive. So for especially for large data center, they're looking for a better and better thermal solution and higher density, because you want to save money, and how you save it is by saving the daily running operation cost, utility cost. So with this high density sharing component design, you're capable to efficiently transfer heat into the air and then pass it out to the data centers, and that's where you save your money. Eventually, you will see your utility bill reduce and break the initial investment you put on the SuperBlade. So it's actually a very great investment for individuals.
For the long-term value, and the bill you pay every month becomes very significant over 3 years.
That's correct. And on top of that, we actually offer centralized management, so that help IT professional maintain this SuperBlade much more easier than regular 1U and 2U rack mount servers. And plus, we have those Supermicro tools compatible with the rest of our APK package, so you can easily to manage not just one node, but the whole enclosure or to a rack level.
And we were talking with Forrest earlier about the Supermicro switches that are being integrated over time into that management tool as well. So you get a management for the entire data center infrastructure, since these are all Ethernet connected. Then you go out into a switch that is managed from the same platform. That's a really compelling story around a large-scale environment that you can automate from one place.
Yes, you can use this what we call Redfish, so the open source software that you can customize your own management software to manage all your blade in one shot.
So this is all Redfish supported?
Yeah,
excellent.
Redfish compatible.
I've heard from a couple of other vendors about how important Redfish is as a standardized way of managing servers, and the Bluefish, is it, for networking? Those standards on API-based management rather than send a series of CLI commands in as your automation tool. And there's a really good story around using Redfish as things scale out. Yeah,
definitely. So today's IT and data center is not about manually implement one by one anymore. People want to automate it. So the more you automate it, the easier, the better for the data center.
Great. It's good to know there's Redfish through these. Well, Sang, thank you very much for joining me on this video. And thank you all for watching with us. Stay tuned for a lot more videos in the Supermicro build. They're live.
Thank you.
I really like that blade enclosure, and just been told that Singh enjoyed doing the video with us so much that he'd like to do more video. So maybe you'll see a build day live on that platform in the not too distant future. One of the things that's coming on the commentary, hi Tom Green, commenting in. He really likes the in the BigTwin, that M.2 boot
For the
device
mirror booting
that's
device,
in.
right?
So
Yes.
and you can get a decent size of device. So all of my systems, I've got the SuperDOM in them, and it's 16 or 64 gig because I'm booting ESXi. You don't need a lot of capacity in there. But if you're booting Windows on these things, then you want quite a bit of capacity. You know, if your software-defined storage uses a full Linux distribution or uses Windows and it's doing a lot of writing, that mirrored M.2 devices is really cool.
I think it's useful for many different reasons. One is if you want to store larger logs for debugging, that's a good thing. Many of our customers want to do mirroring of the boot, that way they can kind of, doing a RAID on that one, so it's really a good thing too. So yeah, and the capacity sizes are increasing. So
well, yeah, in my lab I have 1 terabyte M.2s as the hosting most of the lab. So you have lots of capacity in there. The installs are still progressing. The 6th of the machines, it took me a long time through the small screen to hit F12 at the right moment. Zachary, who has been my technical resources, we've been going through this, looks at it and shakes his head and says, why are you doing it the hard way? He'll be joining us a little bit later and he'll tell us a little more of the easy way in order to kick the machines into Pixie booting every time they come up, or a single time that they come up, because there are a whole heap of automation tools. That's been one of the things that's been a little bit different for this build day to some of the other build days that we've done. A lot of the time I have a subject matter expert from the company sitting beside me, so an engineer who does this all the time. Most of this, it's just been minimal assistance for getting, in particular, the BigTwin up. Once they gave me a BigTwin that was as it comes from the factory, it was really easy for me to do the rest of the build. I could just use all of my standard build tools. I didn't need anything customized for it. I could do all of the resets myself. The whole stuff is handed over as standard hardware, and that's one of the different features. Each build day feels a little bit different, and that's been one of the features here, is that it's been easy for me to work through it with standard things.
And the reason why it kind of becomes as we go along is because all the learning we do with our different OEM engagements, that comes out into our mainstream platforms too. So all the things that you mentioned, all the wonderful names you mentioned, when we help them out, we learn something and kind of really shows making the product much more robust and stable and simple to kind of consume. So that's really what our customers have been looking for, and they really appreciate the simplicity that we bring to the table.
And then your partnerships go in the other direction, down into the hardware as well. And that's one of the other elements that's come through on this, is that there's really innovative hardware that's using the latest feature sets from a variety of different vendors. So we saw the Optane drives in the BigTwin, which is what we're building on. I don't know of any hyper-converged vendor that's currently offering a stock, a model that contains Optane. On the roadmap for most of the vendors, because it makes so much sense as the cache tier, but the qualification process is a little longer, because presumably if a hyper-converged vendor is based on somebody else's hardware, well, that person's got to get it certified first, and then it's got to be certified with a hyper-converged vendor. So at least the first stage I know is done, because the hardware with Optane in it, you guys have certified that hardware layer.
It's interesting you mentioned that, right? Because when you look at it, one of the ways we define Supermicro, one of the ways the customers know Supermicro is we are always innovative. We bring the first to market with innovative products. And that happens because it doesn't happen, it's not a happenstance. Because all these things, well, months prior, 18 months prior, the wheels should be set in motion, right? Here's an example, right, the Optane. We have been working with Intel's design team, engineering team, validating it, making sure that we have the right platform for that one, making sure it really comes up and scales to the application's requirements. Same is the case with the VMware. When we were kind of doing this all flash for the VMware's VSAN team, I remember the instance where we had to put the BigTwin and a car back, drive up to the VSAN team. That's what we do a lot here, right? Whether driving up to Intel, making sure that we kind of have the conversation with the Intel design engineers, or driving up to Palo Alto, having a design conversation and kind of. So that is probably what I would say is unique about Supermicro. And that has to do with the DNA of Supermicro, because we want to get things done. When somebody says, I want this, and even though it seems insurmountable from engineering perspective, we take up the challenge. We say we can do it.
I think all of the major hardware server vendors talk about having partnerships, but I see an immediacy of those partnerships with Supermicro that's not necessarily feeling the same with other vendors, that you're first to market with things.
That's the reason why, right? When the design engineers need a platform to validate their design, or the software guys want to kind of validate their software, they need a platform to work with. And Supermicro is the first one to be there working with them. So that kind of creates a kind of familiarity with the platform, and that continues not only with many of the other startups. That familiarity continues, and when it comes to taking the product to market, they go with Supermicro. Granted, it's an x86 environment. After that, all the players come in, that's fine, but that is what the label we want to be known for. We are always first to market. With any technology, we want to kind of bring a fully baked solution to the market first.
And for customers, that means a period of time where there's a competitive advantage against somebody who is using a vendor that takes more time to get a certified solution out.
It's an advantage to the customer at multiple levels, because this is a product that has been in the labs of these startups or any of these VMware's VSAN for a longer period of time. There is a familiarity. People know inside out how to kind of debug the situation. And to be honest with you, we are huge following in the VMware forums. Many of our engineers in the IT community, they love our products. In fact, when we are at the VMworld, not a minute goes by, someone says, you know what, I have the exact same thing in my basement, also in my data center. So all these guys have this equipment in their basements. That is what they learn to kind of do the certifications, get the certifications. And also they have the same thing in their data center. So that familiarity really helps in debugging and kind of making things right if there are any problems too. So that way, yeah, we are blessed to be working with all these different partners and having the community that really respects us, trusts us to bring the latest product first to market.
And I'm one of the people who has Supermicro equipment in my lab, in my garage. And as I put more of the Supermicro equipment in both the mobile lab and in my garage, I'm looking at what else can I replace with more Supermicro equipment. In particular, it's, for me, the IPMI built into all of the products is really important, because it is in my garage. My home shed quarters is a little bit away, and there's almost a beaten path between the two as I have to walk backwards and forwards, and I don't like that. I would much rather have more IPMI connectivity for managing the equipment. And VMWare, of course, is an organization very close to our heart. Many of our vBrownBag crew and volunteers and the people who consume the vBrownBag content are also very involved in VMWare, and every time they see Supermicro people at VMWare should reach out and say hi. Our 4 nodes in our BigTwin have finally completed building. The ESXi install is complete, and so we'll close out the console. Where are the alerts? Close out that console and the connections into the IPMI interfaces. We're finished with them for now. And what we have is a PowerShell script. As those who've watched the Build Day Live before will be familiar with this PowerShell script, mostly drawn from Autolab. And it goes through and builds my ESX service nice and consistent configuration. Could have done this all in the Pixie boot, the Anaconda install, or the Weasel install as it is with ESXi, and I could have put this all in post, but I like having it in the PowerShell script so I can rerun it later. And it is very much the standard things that I always do, with a bunch of networking and setting up redundant network adapters, configuring up some virtual switch, some IP config, creating some VM kernel ports, creating some data stores and those kinds of things. So I'm just going to drop into a PowerShell prompt and run that script. And we should see things just kick off and start super add host for the Supermicro. So that's going to take a little while to go through and build up the ESXi servers and get them ready. What I noticed was some of the settings that I've got in it require the ESX servers to be restarted. So there's going to be a little while as it progresses. So we thought this would be a good time to talk about the super servers. So we're looking at the BigTwin, which is a 2U rack mount with 4 nodes in it. It's not the solution to every problem. There is no one solution to every IT problem. The Super Server Ultra range is the mainstream pizza box servers, as we normally refer to them. And so we have an outline of what the product set is like and the value out of those. So that's the 1 or 2U video. If we could play that one, please, Jeffrey. Welcome back to the Build Day Live here at Supermicro. I'm joined for this video by Jerry Deere.
Yep.
Jerry, welcome. And tell the lovely folks at home what your job role here is at Supermicro.
I'm the System Solution Manager, and I handle the Ultra product family.
And we've got a couple of the Ultra servers here. So what's the basic concept for the Ultra? What makes them different from the other products in the massive portfolio?
I'm glad you asked that. So Ultra is one of the unique servers that we happen to have. It's focused more on the enterprise class products, and it can really go beyond that. But what makes Ultra really stand out is its versatility because of the modular design as well as the vast expansion and storage capabilities that our servers can have.
But there's real consistency through the series as well. We were talking before that it's a single motherboard across the series, so yes. I can treat them just as if they're sort of larger and smaller versions of the same thing.
Exactly. One common building block, which is the motherboard, and then you can switch out like backplanes, risers, and it can configure into a completely different server. That's why we have a comprehensive, extensive line of the Ultra family, but it has that one building block.
And these are your main consistent kind of servers that are targeted at an enterprise that wants as few decision points as they can, but a bit of flexibility. So these typically come as a ready-to-boot system.
That is correct. So the customer, it's going to be built to order. Customer is going to put in their requirements for CPU, memory, hard drives, and just select the type of Ultra that they're looking for, and they're ready to go.
And that's much more like the enterprise buying experience. Some of the other products are oriented much more towards the cloud buying experience, where there's just a recipe of parts and you can put together exactly what you want, which is great for cloud providers, but it tends not to lead to the experience that enterprises want with some consistency of support.
That's correct. We really want just to try to simplify everything for the customer, so they just put in what they need and it's ready to go.
So we've got 2 servers here. These represent the 1U is the smaller scale in this. There's a 2U. Are there larger models as well?
No, for the Ultra family, we're doing it with rack mounts, so it's going to be a 1U, 2U with a lot of great features.
Right, and we've got, in particular, they're all NVMe. This is one of the cool things that I see in the range of products that I've got. Sitting in the next room, I've got a bunch more high-performance storage products. So this is all NVMe across the front.
That's correct.
10 drives in the 1U, and how many have we got in this 2U?
2U is going to be a 24.
Right, yes. So horizontal in here and vertical orientation in the 2U as usual.
That is correct, yeah.
And there, let me see if I can pop one of these out without getting to the front. This is the standard 15mm carrier, whatever drive you could put, not in the NVMe, you wouldn't put spinning Rust, but if this was a SAS or a SATA configuration, I could have some spinning hard drive in here.
That's correct. We would have a different server with a different backplane, but yes, you could have the SATA SAS configuration as well too.
Right. And then there's a bucket of NVMe on this one.
Yeah, so just really quickly, if you don't mind, I'll talk a little bit about the NVMe. So the way that these two actually differentiate each other is that the 1U10 NVMe is what we call direct attach. So it means that we're providing the full pipeline, 4 PCI Express lanes per drive. So you're going to get the best performance out of each NVMe drive. On the 2U24, because we have 24 drives, you need a lot more PCI Express lanes. Exactly. So you're going to be limited in terms of how many lanes you can pull out of the CPU because you have a whole bunch of I/O that you also need to support. So just to make it plain and simple and just easy to understand is that we do have to have PCI Express switches in this particular platform. The benefit with the 2U24 is that you increase the overall NVMe density by 24 drives, so you can support that many NVMe's, but you also gain 2 full by 16 PCI Express lanes per processor. So if you want to put 100G NICs on here, it's a great combination.
And you'd have a lot of front-end, back-end performance here in the NVMe, and get all of that depth of queuing that you get with NVMe that's so critical for the shared storage workloads.
That is correct.
And still get sort of that balanced throughput, because what you don't want to do is dedicate all of your PCIe lanes to the NVMe and have nothing left to get the I/O out.
Exactly. You got a great box that's doing all this computation, but you need a great network to also put the information out.
Right, and that one will take you've got certified 100 gig NICs for this?
We do. Yeah, we have
Awesome.
multiple vendors that we're working with.
It's kind of hard to believe that 100 gig is being available and a sensible decision now, because the grey here kind of indicates that I started back when 10 meg was a good network.
Yeah.
It's a very long time ago. I want to have a quick look inside this guy. So we say it's the same motherboard as in this one. It's just a little easier to see inside this fella.
Yeah.
And if we slide him back, it really is just very standard server kind of things in parts. You know, lots and lots of DIMM slots. Being a demo one, there's not a lot in there, but you can see there's a lot of capacity for it. Dual sockets. This is that huge amount of PCI Express going forward to the NVMe drives, and that's the direct one. Those are, every lane is direct in.
That's correct. So the architecture that we happen to have for the Ultra platform is that you pretty much hit all the common or the key traits. Dual processors on all Ultra products. It's going to have 24 DIMMs. The benefit with that is that not only can you utilize it for the memory, but you also can use it for, like NVDIMMs, and in the future when new storage comes out on the DIMMs itself, you can actually utilize it on the Ultra platform.
So you're going to be ready when things like the Intel Optane comes out as DIMMs, application acceleration.
Yep, we're actually doing a lot of testing on those type of DIMMs.
That's the nice thing of being just down the road from Intel.
Oh, for sure, and it's showing a lot of great promise. The other thing too is that you also mentioned is going to be the configuration that we happen to have in here. And as I mentioned earlier, was that this particular 1U10, it's pretty much our performance piece because we allocated the full amount of PCI Express lane to the 10 drives. And what that means, it means that we 40 PCI Express lanes among both processors to give you the best possible performance coming out of this box.
So this would be an outstanding high-end database server.
For sure.
And we were discussing that you might also choose to use a similar model for a file server, but rather than using all the NVMe, you might use this SAS that's on the motherboard and have a SAS front end, or SAS for all of the storage if it was something like a file server and you wanted more capacity without getting a ridiculous cost. But still want that consistent experience of having the same model of servers.
Yeah, we actually have a different model that will basically be for SATA and SAS configurations. For SAS, you will need to add an additional controller in there to support SAS, but SATA is going to be out of the box. Okay. It will be a different model because the backplane is going to be different. This one is specifically for NVMe. Although one nice thing with the Ultra family is that we like to include the flexibility. And with each one of our NVMe products, pretty much we have what is called hybrid ports. So as long as the connectivity is plugged into the backplane, like for instance in a 1U10 NVMe, the last 4 drives can also support SATA and SAS as well, as long as the connectivity is plugged into the back.
Little SATA SAS connectors on the back of the backplane here, which you can't see from that side. But yes, that would then let me have some capacity on one side and some performance and do some tiering if this was being used as a storage appliance.
Exactly, because like let's say you had like an OS and obviously you don't want to put your OS on NVMe's. Not that you can't, you could, but it might be a little bit overkill. So you can put in your standard SSDs or SAS drives, you can put into a RAID configuration, and then you can basically have the NVMe drives for your database.
For your application
so
data.
You can have that fast input output and low latency.
And the other place you'd see use for this is where this is being clustered together to build a storage platform, maybe a scale-out NAS or object storage, where a bunch of these together would be built. And I guess you'd probably see that more in the 2U, where you've got all that I/O for the cluster I/O as well as the consumption I/O.
Yeah.
So we've already talked about having the 100 gig Ethernet as the way of consuming this. There's quite a few I/O options in here. I see more than a single PCI Express slot available in this 1U server.
Yep.
What other options do we have in here?
So in this particular case, depending on a 1U and 2U form factor, we have a wide variety of expansion capabilities. In a 1U, we can have up to 4 slots. In a 2U, we can have up to 8 slots. So depending on what type of add-on card you want to add in there, if you need full by 16s, we can basically have special risers that can tie those together to give you that full by 16. In this particular case, if you look at this 1U form factor, we actually have a dual width GPU card in this server, which is meant for GPU computing. So,
and that's unusual to stuff into a 1U server, because usually there's a lot of thermal problems and power supply problems in order to put that kind of device in here. And I imagine there's probably some deployment guides on that, but it's unusual to even be able to put it in a 1U server.
Oh, that is 100% correct. And one of the things that we've done with our engineering is really work on that overall thermal design. So we're able to accommodate dual width 300-watt GPUs and sufficiently cool down the system to be utilized. So it's pretty amazing of what we're able to do, but a lot of our servers support the GPUs.
And that pipelining of really high performance storage out the front into really high performance GPU inside it must be very good for the AI machine learning model training.
For sure, because they're looking for latency and fast storage. So high throughput, low latency, that's the name of the game.
Great. Well, thank you very much, Jerry dear. This has been talking about the Supermicro Ultra, Super Server Ultra series. Stay on the line for more videos from the Build Day Live here at Supermicro. And that 1U Super Server Ultra is actually still sitting in the lab behind us, hooked up to the vSphere environment. And it's actually what's causing all the red that you may have noticed in my PowerShell. I hadn't sanity checked my PowerShell, and it's trying to do work on more than just the BigTwin that we've got. Host 7 is the additional node that is the GPU enabled node. Also, the people watching carefully may have noticed that Sim no longer looks like Sim. We now have Zachary joining me, so thank you for joining on Zachary.
Yep. Nice to be here. Thank you for having me.
Thank you for all of your help this week. So although I said that I haven't had a subject matter expert sitting next to me for the whole week, I have had Zachary coming in, going quite a lot. In particular, helping me with my first deployment of the GPU-enabled desktop with Vue, which we'll come to shortly. But Zachary was also the guy who was saying, why are you trying to press F while it's booting up? So what would have been a better way for me to have been managing the boot up of this bunch of servers?
Well, for the boot up for these servers, definitely recommend, I mean, we have SMCI IPMyTool, which is available Windows, Linux, and you can just give it a simple command, IPMyTool chassis boot dev, and it'll boot to Pixie without you hitting F12. And you can actually build like a file of all your IPMIs, and then just give it one file of your IPMIs, and all those IPMIs will boot to Pixie. So you don't have to screens anymore, you don't have to do any of that. We've included automation tools at Supermicro here, so that you don't really have to do that. You can actually mount ISOs, boot to Pixie, boot to BIOS, change BIOS settings. You can change your whole BIOS from some of our software management tools like SUM.
Right, and SUM is the update manager.
Yeah, the update manager, but it also allows you to pre-configure like your IPMI and your BIOS settings. So I don't know if you remember, but we were looking at some of the BIOS settings for the GPU. So if you ever needed to change any of those, you could do that with our software tools like SUM. You can give it a list of all your IPs, whether you have 10 or 100 servers, and it'll change all the BIOS settings on all those servers, and you can automate it with those scripts. And you could probably include that into your PowerShell scripts as well.
Could do the calls against a local executable.
Yeah.
And
yeah. So if you like installed SMCI IPMyTool on your local Windows machine, you could call that tool with your PowerShell scripts and then have all your systems booted to Pixie, so you wouldn't need to wait for them anymore.
Maybe I should have spent a little more time talking with you this week. So we now, in the vSphere environment, we now have a new cluster called Super, which contains our 4 nodes. I need to move host 7 back out. He's not. Oh.
Maintenance mode.
I always forget I need to do maintenance mode to move things around. He's not connected. That's why I can't put him into maintenance mode. He's probably still rebooting at the moment because my script reboots at the end.
Yeah.
So this is our cluster. The hosts are built up, lots of CPUs, the usual configuration with a bunch of virtual switches with a bunch of networking on them, the same as I always do when we're doing the Build Day Live. The thing that's different here is the storage devices. So we have a bunch of storage, and this is the 6 NVMe drives at the front. We have the the large NAND flash SSDs. So.
Yeah, so we're using two P4800Xs as the caching devices. Those are your 375 gig drives. And then the 3.
And those are the Opteron, the
Optane.
Optane.
Yeah,
Get
the
right
Optane
name.
drives. So those ones are fully qualified. We have benchmarking results fully published. I think those will be on your Twitter feed.
We'll link to you were responsible for getting the VMmark figures out on those. So we'll link to that
all
white
those
paper.
are included. So yeah, if you look at the Twitter feed, you'll see some benchmarking numbers for our VMware VMmark that we had to do basically for our Intel Select branding. But it's a performance guarantee from our BigTwin systems. And we have both of our all-flash NVMe systems and our all-flash SSD systems, both qualified for that.
So the highest performance NVMe and the more budget-conscious.
And what you'll basically see between the two results is the NVMe. I mean, they do actually offer very similar performance when it comes to the VMmark benchmark. But what you'll see with the NVMe is you get better infrastructure operations, so more live vMotion migrations, more storage vMotions, and basically XV migrations per hour. More deploys, so if you're like deploying lots of VDI instances, they'll be able to deploy faster on the NVMe.
Right, but your experience is that the NVMe in the day-to-day operations isn't that significant a change, or is it just the benchmarking that you see?
It's just for the just for VMmark because it uses spec and lots of like CPU and memory-related operations. And since we used the same memory and the same CPU, they have very similar performance. Because
so it's just the storage doesn't change it so much.
Exactly, because it benchmarks the whole solution, right?
And that's the funky thing about benchmarks is you need to choose a benchmark that aligns to your application to get a meaningful result for your actual infrastructure.
So a lot of people use like HCI Bench, which I'm responsible for doing all the HCI benchmarking here. And it's a tool that's available to everybody via VMware Labs. I definitely recommend anybody getting their hands on it and just trying it out in their VMware environment. It's a really cool tool, and just learning how to use it educates you a ton about how VMware VSAN actually works.
Cool. Now, host settings come back. I can take it out of the cluster. So I don't really want it there while I'm configuring VSAN on here. So we could have just run a PowerShell command to configure VSAN, but I thought it was probably worth taking a quick walk through that.
Yeah, definitely.
As a configuration.
I don't think anybody learns anything just by watching a PowerShell script. So.
Which is why we play video while we're running the PowerShell scripts. But VSAN, I've always found, so long as you've got your preparation right, is really easy to deploy out. The trick here is to make sure you're claiming the right disks. And the one thing that throws me in this wizard is it's at the right-hand side here of the distribution hosts. It says 2 disks on 4 hosts. I think, hang on, I've got 4 hosts, I should have 8 disks.
Yeah.
But it's 2 disks on each because it wants a symmetric configuration. So I'll grab that for our cache tier with our 8 342 gig disks, and capacity clear tier will be on the 3.6 gigs. And we just say go ahead and make it so. I've chosen not to turn on dedupe and compress because we're not actually going to use a lot of storage on here. And although there's not a huge CPU load, there are use cases where the CPU load of doing the dedupe and compress is just going to tip the value around. So it's a fun old thing. So this is going to take a little while to run through. What other automation tools do you use for the Supermicro hardware in your lab environment?
Well, I think I would want to talk about outside my lab environment, which is what they're actually going to be using in the data center, which is what we just got qualified for is the VMware VCF, the Virtual Cloud Foundation, which is the fully automation, right, of everything in the data center, from configuring the VLANs on the switches, configuring your link aggregation on the switches, and configuring the vSAN, the ESXi, all of that together, right? It's a virtual appliance that contains its own Pixie server, its own DHCP servers you can deploy on your laptop. And then you can actually configure a whole rack of vSAN in basically, a couple of minutes. All you have to do is give it your IP ranges and your DNS entries and maybe point it and hook it up to your corporate network. and it'll just run on its own, gives you a central pane of glass to manage everything. But I think that's really where it comes value for automation for especially enterprise level data center customers, is the future is going to be with the virtual cloud foundation.
So you've got products that are currently certified on the VMware Cloud Foundation product. So that's a rack scale. What sort of architecture is inside that?
We have two products currently, which is our BigTwin all NVMe flash and our BigTwin SSD. So those are the main two lines of products that we want to be promoting.
And then the network automation is really critical in there, and that's something that I wasn't aware of from Supermicro. So I think this might be a good segue into the conversation we had about the networking. So Jeffrey, can you get up the video we talked about the networking thing? It really was a surprise to me to come in here and be handed a 10 gig switch, 48 port 10 gig switch that has
fully branded Supermicro
on the top. And apparently that's the lower middle of the range of the switches. Yep. Some really pretty impressive gear in there. Ready to go? Welcome back to the Build Day Live here at Supermicro. For this video, I'm joined by Forrest Preston. Welcome, Forrest.
Thank you. Nice to be here.
What is it that your role is here at Supermicro?
I'm a senior product manager for our Ethernet switching product line.
And that was a product line I was completely unaware of until I arrived here yesterday, and I was given this lovely little switch to connect our lab together. Tell us quickly what this is and how it fits in the wider collection of products that you have here. For
this particular model is a 10 gig switch, 10 gig of SFP plus with 4 uplinks at 40 gig. It's part of the range we have that at the low end starts with a 1 gig switch, 48 ports of RJ45. And at the high end, we have our 100 gig Ethernet switch. And the latest introduction we have is a 25 gig switch, which we're quite excited about.
That's keeping the cost per port down at a reasonable level, and
or less.
And so at the sort of bottom end would be typically that gig switch will be used for all of the management interfaces, because you can't negotiate down slow enough on anything faster to get the management interfaces in. But it's all a consistent product set. It's a bunch of 1U servers. So no chassis switches. Correct. It's specifically all 1U, which tends to be the way data centers are being built now, rather than the way they were built 10 years ago.
Yeah, that's
that 100 gig switch is the top end of what you have at the spine of a leaf spine architecture, and then the 25 gig now as the leaf connecting out to all of your compute nodes.
Exactly right. Yes.
Right. What's the management interface on these? What ways can I configure these?
Depending on the product, we generally speaking have both a command line interface, which is consistent with what you see on other leading edge switching vendors, as well as a graphical interface that's web-based. So we have with both options. People who are familiar with the CLI version can have that. People who are more comfortable with the graphical interface can use that.
Great. And I was looking at the graphical interface on this switch yesterday as we were configuring it up to work, and although I'm not a deep networking guy, I found it pretty easy to find where to set up the VLAN trunks and configure the various ports. It was
that's good to hear. That's the hope, that it's easy to use.
Yeah, I like easy to use. Are there sort of central management tools for groups of these, or are we still hitting the UI on each one?
At this point in time, we're just hitting the UI on each one. We've got a plan to integrate it into a management system that's been developed for our Blade system switches, and that'll happen towards the end of this year.
So that's heading into the unified management across multiple sets of assets, which is part of the value. What other interesting and different products have you got in this? So you've got a variety of different switches in. This one has the 25 gig uplinks. Presumably 40 there's 40 gig. 40 gig, 40 gig. I'm confusing my products now.
That's all right.
So
we've got a number of bare metal switches also, which come with no operating system.
Of course,
we've got them in a range starting with a 1 gig aggregation switch, 1 and 10 gigs, a 10 gig, 10 and 40 gig, and then the 100 gig switch that I mentioned that's got 32 ports of 100 gig. Those ports can actually be split. The 100 gigs can either operate at 40 gig or 100 gig, and then they can be split using cables into 4x10 or 4x25. So it's a pretty powerful machine. And as I say, it's a bare metal switch, so you got to buy an operating system to go with it. And we're resellers for Cumulus, which is certified. We're one of the the members on their HCL, their hardware compatibility list.
So across that whole range, from the 100 gig all the way down to the 1 gig, I can have Cumulus.
We got the spine, we got whatever you want for a leaf.
Right. And if I don't want to go with something like Cumulus, then you've got an operating system that I can buy.
We have an operating system that's currently available on the 1 gig switch only. We haven't extended it to the other two yet.
Okay.
You know, it's part of our things that we're looking at doing.
Okay. Well, thank you very much, Forrest. That was a great overview of a completely new product. And
well, let's get the word out. We're happy to have you know about it now.
And I'm glad to hear that more of the unified management across the set, because one of the big value propositions from that integrated set is being able to manage from the same place. So I'm glad that's strongly in the roadmap, and hopefully we see a REST API into all of that, and so we can.
That's part of what we're doing, especially right now with the 25 gig switch.
Great, great. So that helps the story around the automation of the infrastructure in a large scale environment.
Okay.
Thank you, Forrest, and thank you all for joining us. Stay tuned for more Build Day Live at Supermicro. So lots of lovely networking from Supermicro, quite a comprehensive collection there. Now our VSAN has configured up, and well, I guess we should check the status and see what it says about health. I've got a couple of warnings up, and we were talking before about the hardware compatibility warning that's showing up in here.
Yeah.
That this is a spurious warning here about the hardware, the driver versions that are in use. Can you just talk a little bit about what that is and why it's not a cause of great worry?
Okay, so when you build your vSAN, your vCenter, if it's connected to the internet, it grabs basically the HCL, right, and compares your hardware with the hardware compatibility list, as well as the firmware of your hard drives. And for these particular hard drives, the P4500s and the P4510s, they have the same device ID and the same SSID as the 4510. So the 4500 and the 4510 both share a device ID.
Even though there are
two different devices and they share two different firmwares. So it'll tell you to update your P4500s to the firmware of the 4510s. And I think VMware is currently working on that, and that should be fixed in update 1 of 6.7.
So this should just be a cosmetic issue in 6.7, and the correct thing to do is to make sure you have a consistent and up-to-date firmware version across those.
Yeah, just make sure that your firmware, and if it's coming factory from Supermicro, we do all the updates of the firmware before we send it out to you to make sure it's all on the approved stuff. So if it's coming from factory, you should be fine. But if you're building it yourself, it's just something that you should take a look for.
Be aware of.
Yep.
Yeah, it's pointed that the conclusion was that we couldn't get rid of that amber state on the cluster.
No, you won't be able to get rid of that state. But I mean, you can definitely update your firmware of your drives from ESXi. Intel has a tool called ISDCT, and it's VMware compatible. You can install it into your ESXi hosts and update all your firmware on all your drives. You can write your own scripts for it, bash scripts or anything you like. Sure. And get all your firmware updated on your drives with Intel's tools. And
there is one constraint that you need to be using the Intel driver rather than the VMware.
Yeah, the Intel or the Inbox VMD driver both work.
Okay, so just a little care around the install. Mm-hmm. But we do have a cluster. We have a data store here as our vSAN data store.
A nice large
58 terabytes.
That sounds pretty good.
Usable
for a 2U box. I think that seems pretty decent.
And we will hear that there are higher density versions, higher densities available, but not as a vSAN cluster, but as a storage node.
Yep.
But yes, that's pretty impressive. We haven't done benchmarks as part of the Build Day Live, but you've run plenty of benchmarks across this, and I imagine that with that Optane in there, this is pretty high performing.
Yeah, with faults to tolerate equal to 1, I mean, you're going to get about 500,000 I/O and maybe about 5 gig read, 5 gig throughput.
Throughput of read.
Yeah. On the whole device. So you're doing real-time replication, and you're getting a very nice performance. I haven't seen anybody that has any problems with it. I've run about maybe like 640 threads of 70/30 4K workload if we're talking about like synthetic benchmarks, and we're under 5 milliseconds latency. So It's very, it responds very well when you put a lot of threads, right?
Even with the nasty small writes.
Exactly. You're doing tons of nasty small writes, and it responds very well. You get very good latency.
And that corresponds to one of the most unpleasant workloads, which is VDI.
Yes.
There's lots of small writes, and you're still getting
latency is very important when it comes to VDI. Right? You start having latency spikes, you're gonna run into difficulties. So it keeps your latency very low. I think for VDI applications for linked clones, we're able to get about 720 linked clones on this 2U box, and for full clones, we're about to get about 250 full clones, and that's all with less than 1 millisecond latency.
Nice. Nice. Are there published results on that?
There are published results. I will make sure to get that on your Twitter feed.
So we'll endeavor to have that all on the landing page for this at builddaylive.com/supermicro. That's where we're going to collect all of the resources together as your single place to go. Even if we don't get them all out on social media, go back to that builddaylive.com/supermicro. It's our nice new site.
Yeah, but I mean, building out a whole corporate office with 700 users, you can just have a 2U box to run all your VDI.
Yeah.
You have the redundancy of faults to tolerate equal to 1, so you can pull out a node, even it'll still be up and running.
And I'd be inclined to maybe put a couple of, depends on the size of your organization. If you've got 750 desktops, you're going to need some server infrastructure there as well. So you may well have two BigTwins to cover the whole works and have your clusters vertically through them for failure to...
Yeah, if you got the money, you can throw a third one in there too.
Yeah. So nice and modular. One of the things that we're coming back to is around the simplicity of deployment without having to use a packaged hypervisor, packaged HCI, where an hour and a half in, we haven't been going solidly at it, and we have a cluster with 58 terabytes of raw capacity available. The difference between taking probably an hour of effort to build it out and using a hyperconverged product that might take 20 minutes, not a huge difference.
Yeah, and it only took one IT professional.
And this is one of the elements where I think the Supermicro story for being great for hyperconverged for that simplicity, it does still rely on having IT professionals at the organization. So there is going to be a subject matter expert who is going to work with very standardized equipment on the staff. So this kind of story of you can deploy this out and make a hyperconverged environment in an hour and a half does require a professional. It's not for the organization that just has the accountant who knows how to unplug and plug back in again.
Yeah.
But if you have that IT professional, it's really easy to work with. I did literally start with my standard AutoLab build, and in a couple of hours had a working build that was on here. The only trick for me was I had to build an ISO that had the 10 gig Ethernet driver, so the Intel driver for the 10 gig interface that's on there. That's not included in the ISO from VMware.
Nope, it's not.
Didn't take a huge amount of time to build that out, though. It is an absolutely standard Intel network.
You used the base ESXi version, right?
I did.
So I believe there is also a roll-up driver version for ESXi 6.7, and although it will install so many drivers, it installs tons of drivers, which will take a long time to boot. So, but it doesn't include all the drivers. But I always recommend building your own ISOs. Minimize the amount of drivers you want to load. It decreases the amount of memory that your server is going to be utilizing. You're going to be able to utilize more VDI clients if you minimize your drivers.
And every loaded driver is a stability risk, even a very small one. So minimizing those footprints is all good. That's the whole philosophy behind that transition from the old ESX with a service console to ESXi.
Have you guys ever done a video where you do a live ISO build?
We haven't done that. I don't think we've covered it. I went to Vlad and Seget's site. The site I'm blanking on right now, but
it might be interesting to show people the auto deploy feature from VMware on the vCenter. So at a later date, just something to think about.
Well, yeah, that's a good thing to hit up. We can do and explain that. Otherwise, I did follow Vladim's instructions, because the ability to build the ISO is now in the GUI in vCenter, whereas I was used to using PowerShell to do all of that.
I mean, you just turn on one service, right, in your vCenter, the auto deploy, and you can build your own custom ISOs. I think that's a great feature of vCenter. I use that a lot.
So it's nice to have a.
We'll do that next time we're here.
Yeah, when we come back again.
Yeah, absolutely. When you guys do the blades.
When we do the blades, we'll probably need a customized ISO for that as well.
Absolutely.
All right. What haven't we talked? Oh, we've management software. So we've talked a little bit about the management software, but we also have a video recorded with Arun talking about the whole portfolio of the management software. So Jeffrey, I'd like to tee that one up for us. Welcome back to the Build Day Live here at Supermicro. Joining me for this session, Arun Kalluri. Arun, tell us what it is that you do with Supermicro and what we're going to talk about.
Yeah, thank you very much. So I'm responsible for the remote management software aspects of what we call as a systems management products at Supermicro. And so basically what we do is Supermicro has a wide variety of customers, different market segments, all the way from retail to hyperscalers. And each of these market segments have different needs to manage the servers in their deployments. So our products go into managing servers through the life cycle of the server products inside the data centers.
And so this is scales of a few servers, so maybe a dozen servers,
yes,
up to thousands?
It could range from one server, two servers, to all the way to hundreds of thousands of servers. So we have customers managing Supermicro servers in tens of thousands, and even in some cases we have they go into even 6-digit numbers.
Right, that's kind of crazy.
It's crazy numbers, but yes, but that's the reality of today, and in a lot of large data centers, especially large enterprises, big data companies, and public cloud data centers.
And so what's the core management product? Do you have a server management product that is the core of this?
We have several products. So one product definitely is our Supermicro Server Manager, in short abbreviated as SSM. So SSM is a remote web-based server management product that actually and manages servers for all our enterprises and large data centers.
One of the things I want to hit is you say remote and web-based, but it's installed on premises.
It is installed on premises.
It is a server that's installed on premises that then you don't have to sit on the console of it. You can use a web browser to then manage that.
Manage multiple servers, and all the health of all the servers and the asset information and the management capabilities, including the firmware management. Everything can be done through one single web UI interface.
And that there was kind of three ways of thinking about the bits of it. There was the sort of inventory information of what servers have I got and what hardware's inside them.
That's right. That's right. All the serial numbers and everything, all the asset information. And of course, the second aspect is that health information. So again, what components are healthy. And the third aspect is the firmware management. So of course, there's always new releases of this firmware, and they need to be upgraded. And all of that could be managed from a single console.
As I've been going through some of the VSAN deployment at the moment, I think I need SSM deployed out so that I can update the firmware to get the VSAN compatible firmware on my controers.
That is right.
That's kind of behavior that we'd need to have.
Absolutely, and because and since you mentioned VSAN, all our SSM also has plugins that actually go and integrate into the vCenter. So if you're managing a VSAN type of a solution, so there are RESTful APIs on the SSM that goes and that are integrated into the plugins that sit into the vCenter software console.
So we can see visibility of
visibility, everything from the vCenter. Yes,
that's nice.
Yeah.
And you said there was a RESTful API in there. Is that a public API? Can I integrate that into the rest of my environment?
Absolutely, that's a public API, and they can be integrated into your existing infrastructure. So this is the beauty about SSM. Not only can it be used as a single console, but say you want to integrate into your own orchestration or management software, you can take those APIs and integrate into your existing infrastructure software.
And the other interesting place of integration is Redfish as a replacement for IPMI or a proprietary management tool. Can you talk us a little bit through what the strategy is around Redfish?
Absolutely. So Redfish was publicly released around 2015, and Supermicro was, it came out with its support for Redfish. It was the first to come out in the market with a officially available firmware with Redfish API support, and what we have done with that is we are still using IPMI, but because there is some legacy customers who still use IPMI, but also for the new modern data centers, we have these RESTful APIs in the form of Redfish standardized Redfish APIs. So again, with the Redfish APIs, you can just integrate the server right into your infrastructure management software without having to use any of those vendor tools. So basically, you can avoid any CLI-based tools or anything that's coming from the vendor.
Any janky integration between the various parts. It's
various parts.
API call.
Exactly, and you can right away integrate into your infrastructure. So now that's about integrating at a system level. But if you're trying to use a rack as a unit and you want to manage racks, so you can also use our RESTful APIs through our pod manager. So we have our rack scale design based pod manager. That has
now this is targeted rather than at a conventional enterprise. This is more at the cloud scale, hyperscale.
This is more at a cloud scale, hyperscaler level.
Presumably also things like high performance compute environments where there's large numbers of nodes and they scale by 6 racks together is what you deploy.
Absolutely. So even for the HPC, you can definitely use that type of a technology. But for example, for a HPC, they have something called a cluster management software that's kind of doing similar things. Yeah. So definitely, there's a lot of I would say synergies around there.
But circling back to the pod manager, which is aimed at the hyperconverged, that's providing a Redfish type. Is it an actual Redfish API, or
it is a Redfish API coming out? So when we look at it as a system, we are looking at it at a system level. But when you're looking at a rack level, so then you're talking about storage, network, compute, all of them being part of this whole pod management at a rack level.
That I have an API.
Exactly, and you take resources from a compute, and you take a storage from a different box, combine them as a resource, as a logical resource. And expose all that information through Redfish APIs.
So we've seen things like the ultra-dense blade servers would be providing the compute, and the disaggregated storage that we've seen might be providing the storage for it. And these things are being integrated together.
Integrated through a software interface, and that's all Redfish is doing.
And of course, we also heard about the Supermicro's networking portfolio, which I was unaware of before this event. That also, I understand, is being integrated into
the rack scale design, and everything is managed through Redfish APIs.
That's really nice.
Yeah. So if you kind of take a rack as a unit level, of course, there will be a network, compute, storage, everything, and all of and a fabric interconnects that's actually connecting the compute storage in a disaggregated fashion. And you can compose everything. You can compose a resource through all these disaggregated resources, and then go ahead and invoke your Redfish APIs and do bare metal orchestration and so forth.
So you could instantiate 100 servers off a couple of API calls, and then half an hour later you could decommission the whole lot because the job is complete.
Exactly. And when the job is done, you just release everything back into the pool and make them ready for the next task.
There's some serious engineering underneath that.
There's a lot of work that's going beneath, and our teams have been working for the last couple of years in perfecting this.
Yeah. Now, the other management tool we talked about a little was the power management. There's a cool power management tool.
So besides the Supermicro Server Manager, we also have a Supermicro Power Manager. So this is based on Intel DCM. So because we use underlying Intel DCM, we can not only manage Supermicro servers, but we can also manage other servers as well. So now it has a lot more depth in the way you manage the power. So for example, you can actually throttle the power all the way from system level to a CPU to a memory.
So subcomponents within the system
you have that level of granularity. You can have some advanced policies where based on the difference between the inlet and outlet temperatures, you can manage the power. So there's a lot of cool features that you could do to manage and control the power at a data center level.
If you were doing something like trying to use free air cooling rather than use your chillers, you could have an environment that is going to gracefully degrade as the free air starts to be less efficient, and then because you're going to spend more money on the chillers, you may want to degrade a little performance as you're getting across a knee, and then when it's the free air as temperature is getting much less efficient, then you switch the chillers on and automatically your performance comes back up.
That's exactly the point, because sometimes upgrading the infrastructure at the chillers level and everything, it's a more costly, expensive affair. So that's one of the reasons why we can manage the power at the server level, the systems level, at a more granular
component
way.
level within.
Yeah.
And get a graceful degrade rather than on a system that's intolerant of CPU degradation. You can say, well, maybe I'm going to degrade the memory performance because CPU is more important. Or
correct.
Versa.
Yeah, depending upon your application, you can really manage the components power.
And I would think this is very exciting to the hyperscale vendors who are running a single application across 5,000 servers.
That's right.
A little less so to an enterprise customer who's running 5,000 applications across 400 servers.
That's absolutely right. And a lot of times, even in a cloud or a colo kind of a environment, you have a certain power limits. To the
a tenant
rack.
who would be limited to a certain amperage into each rack.
And you want to really have that control
but you want to get all the performance you can get
exactly.
out
Yeah,
of that money. Right. And then underlying this, there are some more detailed management products rather than these overarching consoles. You also have more.
Yeah. So underlying our SSM, we also have a tool called the Supermicro Update Manager. So this is a CLI tool that's used to again update the firmware, everything in a CLI using the CLI interface. A lot of our customers still love CLI interface. Though we have APIs, we have web UIs. Again, it depends upon customer to customer needs, and that's where the Supermicro value is. Like, we do have different products for different customer needs, and this CLI tool allows them to update the firmware, and also it can pull out all the asset information. Right. You can update the firmware again across multiple servers at the same time. So it's not just one server at a time.
It's not a one-to-one relationship.
Yeah. So you can kick off a firmware update process on 1,000 servers at the same time.
Right.
Yeah. So.
Cool. Now we hit all of the highlights of the system management.
Yeah. So beyond that, we also have some legacy tools based on IPMI, such as IPMI View, IPMI CFG. So again, we have the intention to support these tools as long as our customers are still are using IPMI. So again, these are some of the popular tools we have been supporting for more than a decade, and we continue to do that for the customers. And that's another beauty about our tools is the support levels, they go pretty long.
Because you have these large customers who've made a huge investment in Supermicro hardware and methodologies around it. You don't want to push them. You have to change the methodology that you've been using for the last 5 years.
And also, like, our customers upgrade from generation to generation on the hardware products. So the same tools, they expect the same tools to work across multiple generations of their products. And we make sure that the same tools are compatible across multiple generations of our x86 product lines. Not only x86, even some of the product lines that we are working through.
Great. Well, all right. Thank you very much for joining me here.
Absolutely. And thank you for having me.
Pleasure. And thank you for joining us on this video. Stay tuned for more of the Build Day Live videos from Supermicro. So Arun was talking about a bunch of the same things that we'd discussed as being to customers as they deploy at scale, which is really good to have those products.
Yeah, SSM, all those products, SMC IPMI tool.
Yeah.
Definitely needed for an enterprise level.
Yeah, the hand-clicking stuff is great when you have 3 or 4 of something to configure. Yeah. When you have 300 of them, you just can't have enough people to do it, and it doesn't get done right. Yeah. If you're doing it 300 times. I figure I can follow instructions well once. This is why I don't have a day-to-day operations job. The final piece of demo that we wanted to do, final piece of tech we wanted to showcase in here is the ability to use a hardware GPU to accelerate a desktop, because there's a whole suite of products in Supermicro's stable. It's an amazingly extensive stable of products that handles GPU in an x86 server in pretty large numbers. We'll hear more about the portfolio as we go, but we have here the Super Server Ultra 1U that you saw in the video before. We have it built as an ESXi server, and it has that GPU card in it. So the ESXi server is here, and we have that error that throws up on it. Oh, where is it?
Yeah, this is our 1029 Ultra
Yes.
with full NVMe.
Yeah, so it's all NVMe trays in the front, although we've only got one populated because we're only running one desktop on here.
Yep.
Could run significantly more, but that would have taken us past the 7 o'clock last night when Zachary finally persuaded it to play nicely and got it all to work. So we have our server here. It's a moderate configuration. The red status on it was around some of the way the hardware reporting goes on.
I think we forgot maybe to clear the IPMI log.
Okay. So we've done
we were too busy focusing on getting the vGPU to work, and I think I forgot to clear the IPMI log or something like that. Since we got one of this from one of our test labs, right?
Yes, the hardware was on the table here on Tuesday, and then went back and other things were done with it, and it came back again on Wednesday afternoon, and we worked, as often happens for the Build Day Live, we worked late to make sure it was working on the day.
But we also have learned to clear things out and get things ready, which is why we're here early. So.
Oh, yes. So I have a Horizon View environment built, again, standard AutoLab deployment processes to get View built out. And I just want to show you what the passmark benchmark runs like when there is no GPU in the virtual machine. So this is connecting to a desktop running on my lab. So the two Xeon D machines that I brought with me, which is a nice small lab, runs some applications really nicely, but I've got Passmark here, free version, and I'm just going to run the 3D Mark benchmark. What was it complaining about there? There we go. And what you should see is some planes flying, but it looks more like they're levitating because we're seeing about 1 frame per second on this animation, which is not going to be very useful. I certainly wouldn't want to be playing any kind of game on this, not that gaming is particularly business oriented, but any graphically intensive application in this non-accelerated desktop is not going to be terribly pleasant.
Yeah, the virtual machine may be great for like your basic office applications like Word and web browsing and email and stuff like that, but when it comes to video editing, CAD or ANSYS or anything like that, it's just not acceptable.
And VMware's had a software GPU function for a long time as well, where it uses the CPU of the ESX server to behave like a very light GPU. And again, that's good for your office automation apps and for allowing Internet Explorer to actually use a little bit of GPU. But when you put this kind of Microsoft Edge, if you're running a current operating system, and at least I've got Windows 10 in my build this time, but it's not going to change the results on this kind of really intensive 3D application. It's absolutely not intended for that.
No, not at all.
But there are a whole heap of options around hardware-assisted GPUs. So let's take a look back at this ESXi server. Where am I going to see my GPU card in the GUI here?
Configure, and then at the bottom under hardware, there should be a graphics option.
There we go.
There we go. So we have it set to shared dedicated. This is a 16 gig graphics card, the new NVIDIA Tesla V100. And we're going to be running a virtual GPU off of it.
So if you've looked at doing hardware GPU with View, there's the option to do a dedicated where the whole PCI Express card gets pushed into the virtual machine and you get one desktop per GPU card.
Yes.
And that's like your oil and gas exploration kind of use case.
That would be your PCI pass-through.
Yeah. VM Direct Path I/O for those who are looking at it as the straight VMware technology. And I've done that without View just to get some better performance of my, my Windows 7 virtual machine in my lab. Then there is the virtual shared, where you're still using the VMware 3D driver inside the VM, and it can switch between software and hardware.
So you're talking about the shared, not the dedicated shared, but the shared mode, right?
Yes.
So this is where the driver, the ESXi driver, actually controls the performance option for the GPU. It doesn't, the GPU isn't dedicated. It's the driver that controls the actual performance and how the virtual machines interact with the GPU.
But it's still a VMware SVGA 3D driver. It only allows you to do straight graphics applications.
Exactly. So what we're going to be doing is the dedicated graphics, where the GPU is actually, part of the GPU is actually passed through. It's no longer the driver layer that's controlling it.
Yeah.
You'll actually get the dedicated graphics from the GPU into your virtual machine.
And so this is the NVIDIA vGPU functionality, where the NVIDIA driver is inside my VM. And so I can run CUDA-based applications. So I could, using a subset of this incredibly powerful GPU, I could run some of those oil and gas type applications or high-performance compute applications, at least at a test scale, inside my virtual machine, because I have full access to the CUDA instruction set.
Yep. And then you can scale out multiple virtual machines for different office workers. If you have different CAD workers, or different people doing video editing, it'll be easy. So you can scale it out. They can run off thin clients, and you'll have a centralized place to run all your virtual machines instead of having big workstations for all of them. Did the benchmark finish?
I think the benchmark failed because I didn't have I didn't have a DirectX 12 compatible driver.
Oh yeah.
Because the software one is not, and you can see that I don't get a passing score.
No, it's 0 versus the world.
It's a 0 frames per second, or less than 1 frame per second rate on it. So if I take the same virtual machine and I've pushed it across onto this node that's got the V100 Tesla GPU in it, and that we've installed the NVIDIA driver into, connect through View.
And we have the licensing as well.
Now,
that was the most important part.
That was the part that caused us the most pain, that caused us to be here until late last night, because the way NVIDIA's licensing works is you've got to get connectivity to a licensing server. And in any production deployment, that's just a standard part of the build out. And
you can deploy it as a simple OVA, the licensing server, right? You don't have to have a dedicated box or anything. We're VMware guys. We just spin up a new virtual machine, a very small, tiny virtual machine, put their licensing server on it. It's pretty easy to use.
And now I've got a NVIDIA driver in here, got the control panel, and look at stuff in the NVIDIA control panel just as it would if you had a NVIDIA GPU in your physical desktop. And when I run that same passmark performance test, it takes the same amount of time to load up, but when I run the 3D Mark tests, we should see those planes are actually flying a little faster. So we're seeing 45 frames per second at the moment, compared to less than 1 frame per second before. Now, bear in mind that this is a benchmark. It's not designed to look the best on screen. It's not a gee whiz demo so much as what's the deliverable performance. I actually saw better performance in this morning when I was testing before we were on air. I was seeing around 150 frames per second for this. So not quite sure what's gone on there, but significantly more performance here for each of the users. And we're a small fraction of the GPU itself. Cool. Well, there it is running, nicely accelerated. And it may well be that the delay is being caused by having the screen capture software that we use in order to get this desktop into the video, because that wasn't running when I was running the benchmark previously.
Yeah, it could be how your Horizon client is actually interfacing with your computer, and not the actual GPU itself.
Yeah, it was definitely seeing 150, 160 frames per second pretty consistently in here. Benchmark will run for a little while, not particularly exciting to see, so I'm really happy we got that. We'll come back and see the result of that in a minute. So while that's running, Jeffrey, we've got a really nice video talking about the whole product suite that Supermicro has for GPU accelerated servers. And that runs us through. Should be the GPU servers video. So if you line that one up for us, and that'll tell us what you could use to run these video accelerated desktops. Of course, GPUs we also know are really important to people who are doing machine learning and particularly training deep learning models, and that's one of the big places for them. Here we go for the video. Welcome back to the Build Day Live here at Supermicro. For this video about all things GPU, I'm joined by Suresh Irani. Welcome, Suresh.
Hi, I'm glad to be here.
What's your role within Supermicro?
Hi, I'm a Director of Product Management for GPU systems. We have a bunch of GPU offerings for various different markets, and I manage that product line.
So that's for everything from using GPUs to accelerate desktops and VDI, through the high performance compute and workstation kind of use cases, all the way into the newer machine learning use cases as well.
Absolutely. So we cover machines for VDI. We cover applications that are traditionally HPC, which is continuing to grow. But of course, the big one that we are focused on, and that's really growing very fast today, impacting all industries, is deep learning and AI.
And of course, for the process of that is large amounts of data being trained through a model, and that requires vast amounts of computation, and that's being done efficiently at the moment with GPUs, because CPUs simply can't handle that kind of rate of parallel transactions that the GPUs do.
Exactly. So for AI to work as a technology, one of the key ingredients is data and very large amounts of it. You can get a deep learning model to be accurate with a limited amount of data, but that may not be very interesting. For it to reach like 90–95% model accuracy, whether it's image recognition, speech translation, when it approaches the accuracy of what an average human being would be, that's when you can replace a human or augment a human, and that's when the technology starts getting really interesting. For that to happen, what is needed is a very large amount of data and a very large amount of computational horsepower. And as you mentioned, as you alluded to, for that, really today, the main option for doing that for large models with 100 layers or more within the model, kind of the de facto platform is a high-performance GPU or multiple high-performance GPUs. So your training times don't exceed and don't blow up and don't go into weeks. So you can
weeks
do
and years of
training. So you can do it more realistically in a few days. And yeah, so you need a lot of data, and you need a lot of computational horsepower to crunch the data, and that's where massively parallel GPUs stuff like the new V100 with more than 5,000 CUDA cores, specialized tensor cores come in, and sometimes the models are being trained on not just one GPU, but even a bunch of 4 or 8 or even more GPUs.
Right. So what's this piece of hardware we have in front? It's a server with a bunch of heat sinks, but that's a little more heat sinks than we normally see.
Right. So this is one of our systems. We probably carry about 10, 12 systems. We go from 1 or 2 GPUs all the way up to 8 or 10 GPUs, and we've got systems under design that are 16 GPUs in a single node. So we've got a wide range. I wouldn't be able to fit all of my offerings on this table. This is one of our guys out here. This is a 1U 4 GPU server. This is a dual socket with 3 UPIs between the 2 CPUs. This is Skylake based. I also had a version that was Broadwell based. But really what's interesting out here are these guys in the front. These are 4 high-performance V100 32 gig GPUs. Really, a GPU is a misnomer in this case. It's like historical thing, GPU. Although it's not doing any graphics processing this time, it's really targeted high-performance AI workloads. So before I get into that, I'd just like to differentiate that traditionally GPUs came in a form factor that looked like that, a double width GPU card that plugged into a PCIe slot. Recently, NVIDIA has, for the last 2 generations, started offering a separate form factor, which is more like a CPU socket. It would be, you would be able to see it under this heatsink, which goes directly on the motherboard. We've got these large 1U heats to cool 300 watts of processing power. So within this 1U, you really got 4 GPUs and 2 CPUs, so 6 high-performance processors running here. And these are connected with NVLink. NVLink is the interface where GPUs talk to each other directly. And if you've got a large training model which is distributed across multiple GPUs, there's going to be a lot of GPU to GPU communication. And with NVLink, you avoid having the hop to go through the PLX switch CPU and come back. And these guys can talk to each other directly. With the V100, each GPU socket has 6 NVLinks. So each of these 4 has 6 links. And each GPU is connected to every other GPU, the other 3 in this system, via dual NVLinks. And those links go through our PCB. They're built into our GPU board. If you look closely, we have a separate board for the GPUs and for the CPUs, and we connect them across PCI bridges. So the PCI runs between the 2 boards, and this gives us flexibility to rev this system quickly when a new version of the CPU or GPU comes out.
And that's it's a little hard to see in the video, but there is literally a gap between the board at the front. Where this rail is at the top, there's a gap between the boards, and all that connects is these thick braided cables that are bringing the PCIe signals from the server at the back through to the GPUs at the front. And when these GPUs are no longer sufficiently powerful, this board could be switched out and,
exactly.
and new GPUs in.
They're sufficiently powerful, but there's always something newer and faster and higher performance coming out. Moore's law is slowing down, but the industry is not. There's more innovation going on. There's more happening on the parallel processing
stack. It's earlier in the life cycle of these GPUs than it is on the CPU. So there's still more innovation to be had in there.
Yes.
And of course, there's more money to be made from that innovation compared to innovation in the CPUs.
And you were mentioning that the gap is hard to see. And that's one of the kind of things in Supermicro's DNA. We pack it really close and fine, but we don't compromise on the thermals. So we like to have compact, high-performance solutions, but definitely with a lot of thermal capacity, so you don't see any GPU throttling.
And that's why there's this vast bank of fans at the front.
Exactly. So when I talk about a GPU system or a GPU server, really the soul of a GPU system, soul of these systems is they should be able to mechanically fit and support the number of GPUs that they're rated for, 4, 6, 8, whatever the number may be. There should be enough redundant power supply, enough power delivery to get all the amperes, the current into the GPUs, especially when they're cranked up and running workloads at full capacity. And the third aspect that these are designed for is there's enough airflow in this one going front to back to make sure that there's enough cooling capacity to get all the thermals out. As I mentioned before, we have 6 high-performance processors in a 1U. So mechanical fit, power delivery, and thermal airflow to cool these. And also more and more people are now starting to look at liquid-cooled systems, especially for high-performance GPUs out here, although bulk of the market still remains air-cooled today. But as we see more data set, more new data sets coming out with liquid-cooled built-in, liquid-cooled infrastructure built-in, we'll see more people wanting to tap into that and leverage that available liquid cooling infrastructure.
Cool. So this is very much the AI deep learning
Yes, it can also be used for some guys doing high performance computing. There's all different variants of that, which be used in oil and gas. It can be used in scientific research, particle accelerators, all different kinds of applications. Those guys also need very high levels of performance who would use this, use a system like this.
What about this rather taller unit that we have?
Yes, this is our 4U4 GPU system. What it offers us is 2 high-performance CPUs and up to 4. I've got 2 loaded out here. I'm just kept the other 2 slots open so people can get an idea of what the system looks like. 4 high-performance CPUs. We support both actively and passively cooled GPUs, so we can support the NVIDIA Tesla line as well as the Quadro line, and a lot of I/O in this system. This one is kind of unique and interesting is because it comes in a tower workstation form factor, so it can be used under your desk. It also comes with a rail mounting kit, so it can work as a rack mounted 4U. So it's a server cum workstation form factor, one of our popular selling models. I've also got a similar version of this, but which does 8 or 10 GPUs. So as I said, we've got a lot of different products, and we are very proud to be developing a future generation product which will support up to 16 GPUs in a single node. So definitely the trend towards having the GPU being used for high performance computing, for AI, is not just a one-time thing. It's definitely getting more and more adopted.
It's one of the interesting things as we hear the discussion about software eating the world, that everything is software running on commodity compute. That definition of commodity compute is changing with GPUs and at some stage FPGAs as well.
So historically over time, people have talked about the killer app. Maybe 20 years ago, maybe I'm dating myself, it was Microsoft Office, and then it was the internet, and then it was high performance video. Really, my perspective is in today's world, the killer app for hardware is AI and deep learning training with large deep learning models.
That it requires so much hardware. One of the other things I wanted to point out about this guy is just the size of the CPU heatsink in here. It's probably a little hard to tell from the perspective, but these CPU coolers here are almost the full height of this 3 or 4U enclosure. They're massive, and so you're not putting a low power CPU in there just to drive the GPUs. You're actually getting fairly serious CPU power.
Yes, some of the applications can be mostly GPU centric, but there's a mix across the board. Some do need, like VDI will need a 50-50 workload. They not only need a powerful GPU, but they also need a powerful CPU to do the heavy lifting, to do the pre-processing and feeding the workloads into the GPUs, keeping the GPUs busy. So we like to over-design, have thermal capacity. These can comfortably handle the top bin of Skylake at 205 watts. With Cascade Lake and future products coming from Intel, I'm sure that the CPU TDP will be going up, and we'll have definitely a lot of thermal headroom in the system to handle those higher performance CPUs coming and higher wattage CPUs coming in the future that we anticipate.
The other thing I noticed is, although you talk about this as being a workstation chassis, it does have redundant power, just like the server class. So when this is put into a rack, it is a full server grade of availability, not a
as I said, it's a hybrid. It's definitely a server class product,
and not a light device either. This is why we had you bring the smaller devices in. The table probably wouldn't have coped with some of the higher end.
Yes, if I got my 10U 16 GPU system, we'd need a reinforced table to hold it up here.
Great. I imagine you'll be showing this at GTC.
Oh, absolutely.
In the near future at the conference. When is that and where?
So GTC is now almost like a worldwide conference. There's the, I think I would call it the Anchor show in San Jose. And then they have regional shows around the world. I'll be traveling in a couple of months to GTC Japan to showcase and highlight some of these systems and also talk to some of our Japanese customers. Supermicro GPUs have been established in the industry worldwide, and we ship to multiple tier ones across the globe.
Great. Well, thank you very much for joining me, Suraj. And
thanks, it was a pleasure.
And thank you for joining the Build Day Live here at Supermicro. Stay tuned for more videos. So Suraj has quite the sweet for GPU computing.
Yeah, it's a very exciting product, and then like I said, there are a lot of other technology developments happening with other providers. So it's going to be getting much more exciting as we go in the next 9 months, 12 months kind of a thing, which I cannot reveal more, which I did, but stay tuned.
And that's kind of a theme to some of the things I've been talking with Zachary about as well. He's working on things that aren't going to be public until 6 months from now, as things get released out. We want to talk a little bit more about storage, because we've got a couple of videos that we're not going to have time to fit into the live stream. So there's some video around disaggregated storage, the ability to take all of those SSDs or Optane drives and put them outside of the chassis and put them into a dedicated location and attach them back, not as a storage array, but actually as a PCI device that is outside of the enclosure. So disaggregated storage. We've got a nice discussion on disaggregated storage, and particularly that one talks about Intel's ruler form factor solid state that's really new, and you can see how excited I am about actually having it, because I've never seen it before and never come across any other coverage of it. How's that partnership with Intel around developing those kinds of products?
So as you know, with Intel, we have been involved from day one with Intel, and Intel to kind of bring the latest technology to the market first because of our willingness to work closely with their engineering teams to make it happen. So for example, NVMe, right? We were the first ones to the market with hot pluggable NVMe. I still remember the day that was like idea of 2015, where we kind of put the product out there and said, go ahead, do the hot plug. Even the customers out there were kind of hesitant to kind of pull it out. So that way, yes, we are very closely tied with Intel, lock and step to kind of get the best products out in the market. Another case in point is the opt-in, right? We got the opt-in products. If you look at it, most of our portfolio covers opt-in products where it kind of provides the best TCO.
So particularly in use in things like the storage products in order to provide that caching to give the right performance or equally really good read performance for the hot data. And one of the other videos that we have talks about some of the more well, one of the videos is around the 60 hard drive enclosure. What was it, 4U 60 hard drives? Ridiculous amounts of capacity.
45 bay, 90 bay, 60 bay, and 90 bay. That's the reason why when you look at storage, right, we are like a one-stop shop. Whether using it for mission critical applications with opt-in kind of a thing.
Lowest latency possible, highest transaction rate.
We have it. We don't have one or two products, but we have multitude of products like you have seen and videoed right in the past couple of days. And when it comes to tier 2, tier 3 or archival purposes, you got the spinning drives, 45 by 60 bay and 90 bay too. That way, front loading, back loading, it depends how you want to kind of do it. So that way we provide a wide variety of choice for our customers to pick and choose what is appropriate for their use case, for their application.
And that's one of the things that's come across is that there's a lot more of a consultative engagement with your enterprise customers than I was expecting. When I look at the Supermicro website, there's just this mountain of different products available. And it's kind of daunting the amount of choice. And so can you talk a little bit about how that consultative engagement works?
Yeah, so sometimes I feel that it kind of hurts us having so many products, but here is the thing. All those products were kind of made because there was a demand for it, the customers were asking for it. Now you can say, how can you scale going forward? Because we have 5,000 products out there, SKUs. But here is how we kind of simplified it. Modularity is what we kind of went after. Each of our things are based on modular blocks. That way we, depending upon the configuration, depending upon the form factor, we bring the different modules in and we test it, validate it, you have the product. So that way from an engineering point of view, that's another reason why having an in-house design expertise is very important, because we are able to think forward. That way when we design something, it is to make sure that it can scale to multiple platforms, multiple form factors, and having that really helps us.
So you get things like the Super Server Ultras that all share the same motherboard. You get most of your servers use that same modular network on motherboard.
And that modularity is what we are taking it to the next step, and that's where your disaggregated servers come in, where we are kind of disaggregating the compute and memory module out. I/O networking, we already kind of modularized it with this IOM, right? And then the storage, that way depending upon where and when and how you want to upgrade, you're able to do it rather than doing a rip and replace forklift refresh. So that is a huge benefit to our customers, and we are able to kind of demonstrate the best TCO, and it also plays into our green computing because you're not kind of contributing more to the e-waste.
It's not a rip and replace, it's upgrade the pieces you need.
So that's
the other element in the disaggregator is the rack scale architectures, where you're enabling what other people are calling composable infrastructure, where automation can build together the collection of compute, storage, and networking that you need for a workload, and then release it back into the larger pool when it's no longer required. And so fitting into more of the DevOps methodologies that we're seeing companies wanting to deploy.
Yeah.
The other element that I wanted to return to, I'm always interested in what's the international footprint and presence like. One of the things we've talked about briefly, can't remember whether it was on camera or off, is that you have manufacturing and design here in San Jose, but you also have other locations around the world with the same manufacturing and design being done locally.
Yeah, so you're right. When I talk to our customers, I'm surprised that we manufacture, we assemble systems in the United States.
Yeah,
still.
I'm very surprised because the perception is that you're a Taiwanese company, but it's absolutely not.
Exactly. It's a company headquartered in San Jose, USA, established in the USA, right? But here is the thing. right now we are sitting in the design center building. Right next to it is assembly manufacturing. For all the customers in the North American region, this is where we ship from, California. But what we did was we have a regional headquarters in Taipei, Taiwan, to service the East, and then we also have a regional headquarters in Netherlands to service our European customers.
Yeah.
So, and the way we build it is most of the design and initial kickoff happens here, but we kind of mirrored the same thing in our regional headquarters too. So we have the design staff, we have the PMs, we have engineering, we have support staff, we have the assembly, so that everything that can be done there is done, and they don't have to wait, the customers don't have to wait for support until the sun rises on this coast. So everything that is happening there is localized, they get good support, and then of course they always have a thing to fall back on the headquarters to get more support. But 99% of the time, all the things that happen there are localized in that region, so the customers can get the best support and service possible.
And I imagine that's incredibly important, both in the Asian region with so many languages, and in Europe again with so many different languages and different environments that will drive different product requirements. Now, we have joined us for this week at Supermicro has been Keith Townsend, CTO advisor. And he's done a bunch of video that's going to be progressively posted up on the CTO Advisor channel on YouTube. But Keith and I sat down yesterday afternoon for a quick chat about what his impression of Supermicro is. So Jeffrey, if you could play that one for us, please. Welcome back to the Build Day Live here at Supermicro. And we wanted to feature a little some of the other content that's being created as part of the Build Day. So I'm joined by my good friend Keith Townsend. Welcome.
How's it going, Alistair?
We're having a great time here. Hopefully in the live stream it's been as good as it has been before the live stream. You've been here today talking to some more of the executives. So firstly, for our audience, the three people in our audience who don't know who you are, would you introduce your role and what it is that you do? And
I am Keith Townsend. I'm the CTO advisor. You might have seen some of my content on the CTOadvisor.com. I have these executive level conversations talking about why executives and architects should either recommend or buy stuff like the BigTwin.
And so if you're the normal vBrownBag audience who's very technically oriented and that likes the engineering depth, the content that Keith uses is really good to kick up to your manager or his manager who speaks a completely different language. And it's one of the things I know Keith learned as he transitioned from being a hands-on engineer to more management focused, is the words don't mean the same things at different levels. And so our video content is wonderful for engineers, but Keith's content is great for the decision maker. So getting the decision to buy across the line, technology needs to be right, but the business case needs to be there as well. So what sort of conversations have you been having with the Supermicro executive teams this week?
So a lot about dispelling a lot of, I think, FUD about Supermicro. You know, Supermicro is in what they're calling the 3.0 version of their livelihood. 1.0 is what, you know, Alistair, we probably remember Supermicro as the motherboard company when we're building either a server or a desktop PC. Supermicro motherboards were, you know, the name of motherboards. Now they're, you know, a proper server class solution where they're taking, you know, chassis like the BigTwin chassis and doing all the cool things and making true data center solutions, not just subsystems.
And one of the things that I've seen is the alliances. Did your videos talk about the alliances with the other?
So not just the alliances. Obviously, you guys are building VSAN on the BigTwin and the integration with OEM partnerships such as Nutanix and the like. They talked about that, but I think what was more enlightening was their capability to take that experience with their partners, whether it's VMware, Nutanix, other OEM partners, and push that capability down to the customer and take engineering requirements. You know, if you're going to buy a few dozen clusters of BigTwins and you needed to run at a certain temperature, you needed to have a certain form factor, they can work with you, which is an interesting piece. They engineer and manufacture right here in Silicon Valley and San Jose, and I thought that was one of the compelling parts of the story.
That's a little surprising because we associate Supermicro as a Taiwanese company,
Yeah.
and we think that all of the engineering and manufacturing is done in Taiwan.
No, which they do some manufacturing in Taiwan and other parts of the world, because it makes sense. You know, just as there's a quick, you know, from idea to being in the customer's hands and having that manufacturing done here in the U.S. Same thing happens in Taiwan, is to have that same type of capability for APAC.
Great. Well, thank you, Keith. You've got, how many interviews did you do today?
I did 4 interviews, all talking from the ranges of how do you buy a Supermicro solution to support, how do they support it, and then how do they, you know, compete with larger players in a market. You can find those videos over on ctodose.com and related blog posts on the ctoadvisor.com.
Excellent. And that content will be coming out over the next few days.
Over the next few days, it should be, you might see a couple of videos trickle down as Build Day Live kicks off. You can go to CTO Dose, and then most definitely a couple of days after the Build Day Live shuts down, you'll be able to continue and forward that content on.
Right. So keep watching for more of the CTO Dose content from here at Supermicro and from other vendors around the world. And stay tuned for more of the Build Day Live here at Supermicro. So do make sure that you check out this guerrilla guide to the Build Day Live here at Supermicro. The ebook should be published in the next couple of weeks. And check out the Supermicro stand at VMworld. You may be able to pick up a paper copy of all of your own. Of course, if they don't have it on the first day you're at VMworld, check a little later. It may just be delayed coming from the printers. So Sim, we're coming to the end of this Build Day Live, and I think we've had quite a lot of story around the technical lead that Supermicro has, dispelled some of the notions about Supermicro as a company as being the huge menu that you have to work out entirely for yourself and hardware that's being shipped from Taiwan because that's where the company is, to finding that lots of customized and consultative engagements to build good solutions for customers. The reason there's so many things in the catalog is customers ask for them. One of the things we were talking about in one of the breaks was that the whole network line came about because customers asked for it. Can you run us through a little bit about how that came?
Yeah, absolutely, right. So when you look at it, we were doing a lot of compute products, compute servers, and then the storage servers. And then the top of the rack, they used to depend upon somebody else to provide the networking part of it. And as you know, currently, pretty much everything is a pretty leaf-spine topology, right? Everything is, all you need is simple routing protocols to be there, and then you're done. So a lot of our customers are saying, if we can provide something like that, no frills, basic networking, that can really kind of match up with our compute and the storage longevity, they were all up for it. And that's how we started our networking line. And today we have 110, 25, 40, and 100G also. Right, on both an Rocky also, that way you have converged Ethernet also. And the advantage is it's more importantly, and then again, people know the brand, Supermicro brand, and it's easier to work with. And we also extended that to kind of open networking, right, with SDN coming in and SDDC. So we work with Cumulus networks. We allow for the ONI boot, and then you can kind of bring in your networking on the open networking ONS kind of a thing. So that's really a very good, it's catching up with the customers, right? But then again, having said that, when it comes to networking, I know many of our customers have their own choice. There is it's just like a religion kind of a thing when it comes to networking. So we respect that. So we kind of are resellers for Arista. We partner with Cisco and all the other networking companies, so we can kind of do a rack and stack with the choice of networking gear and compute and storage from Supermicro and ship it from the factory itself. So that way we are giving more choices to the customer.
I like the target of integrated management between the compute and the networking. I think that's a really good thing to have as a reason for using the one vendor for the different products. And I imagine that the networking equipment is priced as aggressively as the compute equipment is, and that's something that's attractive to customers as well, having sufficient features but not bloated.
Yeah, absolutely. what we bring to the market, right, as always from Supermicro, cost efficient, but more than that, performance oriented, high efficiency performance, right? So that's definitely there.
So as we draw to a close, let's think back on what we've shown in the actual build. We took ourselves a nice BigTwin, 4 servers in 2U, full performance up to 200 watt CPUs and 2 of those in each of the nodes. I remember from the video looking at the BigTwin at the beginning that there was this gap in the heatsink on the front CPU so that cold air was getting to the back CPU. That sort of speaks to the engineering thinking. It's one of those things that is just so obvious when it's done, but the inspiration moment to realize you needed that was the way to do it is pretty cool. We took that, we deployed ESXi onto it. Obviously, I'm not good at automation because I hand configured each of the machines to Pixie Boot when I should have just had a single script that would have powered them on and told them to Pixie Boot for this one boot. Then once ESXi was installed, configured them up to join my cluster and deploy VSAN on top, so consume all of the Intel NAND, the Intel Optane, the 3D crosspoint storage in there, and make ourselves a big VSAN cluster with just under 60 terabytes of raw capacity in 2U, along with 8 sockets at 20 cores, and we didn't have a lot of RAM in these because the BigTwin, we've just had 387 or 300 and something.
But it can go a lot more, 3 terabytes per node, 12 terabytes per system, which is any of the densest in-memory compute, throw it at it, happily it'll
So that would be even a reasonably substantial SAP HANA would sit on top of that and perform really well with all of that high performance storage as well. The other thing that we showed was just a single GPU accelerated virtual machine, because you can go down to a small scale. We did that with a 1U server with the latest Tesla V1000 in it, which there's some engineering required in order to get that much power and that much heat through a 1U server. And we saw significant improvement in the graphical performance of that desktop. We still have barely scratched the surface of what it does. And
like I said, we got 4,500 different SKUs and counting. So yeah, absolutely. But like I said, this was a very interesting discussion, right? What we had today to kind of go through different product portfolio and how we are doing it. And oftentimes, so when it comes to Supermicro, people think, yeah, they build the hardware platform. But like what you had the discussion with Zachary is, we bring a lot of IP on the software front too. That way it is like an end-to-end solution, whether it is VMware or open source or a Microsoft, we have solutions to cater to our customers' requirements in the mission critical, tier 2, tier 3, as well as in the disaster recovery. That way we cover the entire gamut of their needs.
Yeah, because thinking open source and things like running Hyper-V on the BigTwin, or running something like OpenStack or Red Hat's enterprise virtualization, these things all run perfectly well on the. In fact, one of the systems that I had came with Red Hat on it before I knocked it over and made it into an ESXi server. So lots of openness of support in there. I guess as we come to a close, call to actions and things to do. Oh, Jeffrey, you've got some news for us.
Oh yeah, no, I to thank everybody that was on the chat. We had Tom and Alexandru and Paul. Paul did ask the question about doing the RAID 1 mirror on his ESXi, which we did, one of the videos does discuss that a little bit. So which video do they need to?
So that was in the BigTwin hardware tour. We talked about the add-in card that puts 2 M.2 SSD devices inside each node in the BigTwin, so you can have potentially a terabyte SSDs mirrored inside, not occupying any of the hot plug bays in the front as your boot device. Now I think for Paul Barron at tinkertry.com is his site. He's got some really good references about using particularly Supermicro hardware as home lab for whatever learning purposes you have. I don't think BigTwin is in scope for him because it's not really a home lab, although I would love to have it as my home lab.
I'd love to have
I'm sure he would love to have one too. Paul is a good friend of ours. He's like covers our Supermicro products.
Oh yes, has done. He introduced me to the servers that I now have.
All right.
So really good stuff there.
So yeah, if you have any questions after this, feel free to contact us. If you go over to the builddaylive.com/Supermicro page, there is an area. There'll be an area where you can ask questions. You can definitely sign up, and Alistair will get to you and go from there. So, and of course, remember all those hashtags: Supermicro BDL, BigTwin, Optane, and resource saving. We've got them, some of them right here. So. And follow Supermicro's SMCI Twitter handle as well as Build Day Live, because we just built out Build Day Live, which is really cool. So, I'd like to thank you guys. I'd like to thank Zach, and I'd like to thank Kristen, who you're going to see in a second here. And Desiree was just amazing. Look for the rose gold haired woman in Supermicro. Let's see, we had Yen and David, and who else can you think of?
We've had so many people helping us through this. Most of the people that you haven't mentioned have been on camera, and so you've seen their smiling faces.
Yeah.
But the team has been really friendly, from the security guy standing outside who greets us with a smile every day.
Yep.
Receptionist who we sign in with, the security guy who had to let us in, different security guy who had to let us in twice this morning.
That's Jose.
Yeah. Jose, yes, yeah. Thank you, Jose, for letting us into the building so we could be prepared for the live stream.
Yeah.
Now, do sign up for the notifications on the builddaylive.com/Supermicro. That notification is, some of you were told to wake up in time for this live stream. We'll also let you know when the videos are posted onto YouTube. And we might just twist some arms here and see if we can get some swag sent out to a couple of people as well. So sign up for that, and some notifications will come out. And we'll also send you the link to the ebook version of the Gorilla Guide that the actual Tech Media guys are doing for this edition. But of course, you can also catch up with Supermicro at events that are coming. So we'll thank you very much. Oh, one person we have not thanked, Jeffrey, is my lovely wife Tracy, who has been running all of the social media. So all of the tweets that you've seen out on vBrownBag.com, our vBrownBag account, and the Build Day Live account, those have been Tracy, and she's been doing a fabulous job of letting you all know what's been going on in here. Something that we never get time to do, as we're rushing around making sure the video gets done.
So the funny thing is, if you look really hard when we're on the shot of Alistair, and you look behind the screen, I'll show you, there's Alistair's shot. You can see Tracy slightly blurred in there. And of course there's Zach. Melissa was next to Tracy
Melissa
for a while.
Keith's wife.
And she was taking some pictures. So thank you very much as well for that. And thank you guys for being on. This is the largest audience we've had so far on a Build Day Live, and that's awesome. So
keep building up the Build Day Live, and do keep watching for us at builddaylive.com for future events. But right now, we're going to close out with two other people. So David Perez, who was my first contact at Supermicro for setting you for running this through, and Kristen, who you're about to see, she's been awesome helping us through. Kristen is going to take us away with an outline of some of the places you can see Supermicro in the coming months. So thanks very much for joining us at this Build Day Live, and stay tuned for further. Welcome back to the Build Day Live here at Supermicro. We've managed to persuade somebody to come on camera that's not normally on camera. Joined by our primary on-site contact here, Kristen Owen. Kristen, thank you for joining us and taking the suggestion that you should come and talk a little bit as well.
Thank you for twisting my arm a little bit to be here. Happy to be here.
What is your role here at Supermicro?
So I am the Senior Director of our enterprise marketing activities here at Supermicro.
And you've been pretty busy. There's been
I have been. You guys have been keeping me on my toes today. And
one of the things that we talked about was that we see Supermicro at a lot of events. I've talked to Supermicro at events all around the globe. Mm-hmm. And since we're just having a fairly limited time to talk about the products here at the Build Day Live event, it's worthwhile to highlight some of the places that people who are viewing can come and find Supermicro in the coming months. So you've got a whole heap of different places that
Absolutely.
You're going to be.
Yes, we're keeping ourselves busy the second half of this year. So actually next week we're going to be live in San Jose at the Flash Memory Summit.
Right, so and that's the first week of, where are we, August?
Oh my God, I said May. It is August, see? We're just, time is flying here. So yes, first week of August, we'll be at the Flash Memory Summit here in San Jose. And we have some of our esteemed product managers that'll be speaking about some of our JBOF and Optane-based systems that we'll have at the show.
And there was some of the things in that JBOF presentation that we talked about there's things to be announced at Flash Memory Summit, so that is just next week.
So tune in. If you're in San Jose or if you're traveling in for the show, make sure to see us there. We'll be partnered with Intel, so always easy to find Intel at these events for sure. Coming up after that, we'll be at VMworld.
And you'll be a sponsor of the vBrownBag TechTalks at VMworld, so we'll see not just your presence in the Solutions Exchange, but also, I believe, Sim, who will be with me. Well, if you're watching this as part of the live stream, he's been with me all day.
All day.
But he will also be presenting for us in Las Vegas, and you'll have a full stand at the Solutions Exchange.
We will. So we're very excited for that show. That's a big show for us. We'll also be at the VMworld that will be in Barcelona later in the year as well. So always a good time showing up at VMworld. And then we've got supercomputing coming up. There's the Cloud Expo in Europe that's coming up. Intel's doing a cloud summit in China. So as you can see, we've got a lot of things that we'll be doing, not just here locally in the Americas, but also around the globe.
And going a long way past the data center infrastructure that is at least the origins for the vBrownBag side, and into a lot more of the cloud scale providers and the enterprises that are moving towards on-premises cloud scale environments.
Yes, absolutely. We'll be hitting some other shows too, like GTC, right? That'll take us outside.
That's the graphics and
exactly.
There's now presumably lots of AI compute generate the machine learning.
Absolutely, hot topic, right? And we're doing a lot around that. So we will have some announcements later in the year, what we've been doing there.
Right.
So yeah, lots of shows. Looking forward to meeting people and talking more about our technology. We've got some great products that are coming out. We'll be speaking more specifically at these shows about our blades that we have, the NVMe solutions, U.2, JBOF.
There's a lot of these products that are around really high density, both in storage and in compute, and about new things that we haven't seen in the market, new form factors, and basically technology lead in a lot of these things. And of course, that's the thing you'll show the most at these shows.
Yes, we love to talk about how we have such strong partnerships with technology manufacturers. And because of that, we are able to come out with first-to-market technology. So right when the Intels of the world are announcing their latest technology, we come right behind them with, on same day, new products and things. So
and
we're excited.
That it's only a 5-minute drive from your campus
to
their
campus. Right, they're right down the
campus.
Street. Don't give away our secrets. No,
That's right.
it helps being so close to them.
It's at least 20 minutes to get up to VMware to work on the alliance with VMware.
Right. But yes, we have lots of great alliances, and we like to go out to these shows and work with our partners there. So if you don't see a Supermicro presence, we're probably there somewhere with one of our
There'll
partners.
be a logo inside somebody else's
There'll be a logo
booth.
somewhere else, exactly.
Great. Well, thank you very much for joining me, Kristen. And thank you for joining us for the Build Day Live videos. Keep tuned for more of the Build Day Live here at Supermicro.